Hello, and welcome. Welcome to Audio Visualization in Unreal Engine 5 for Beginners course, in which I'm hopefully going to teach you the basics of how you can kind of set up a framework to visualize songs and whatnot. So this course is going to be divided into three parts, into three chapters, if you will. And by the end of chapter number 3, you should have something similar to this. A space in which will reflect audio or music that's playing. So first chapter is going to be us creating this kind of a little menu icon where we can select a song and we choose any song MP3 file that you want, hit open, and it starts playing. So that's step 1. I really hope that right now it's not blasting in the recording. Anyway, step 2 is going to be creating a material that displaces and reacts to that song, just like that. And step 3 is going to be using pretty advanced, I would say, exporting, importing techniques from Rhino and Grasshopper to get an array of shapes that react to the music as well. So while step 1 and step 2 are enough to visualize music or to visualize sound, step 3 is just going to be a little bit of a bonus for those of you who do use Rhino and Grasshopper and that just want to kind of bring this one step further, I would say. Anyway, with that being said, by the way, if you just want the files, as per usual, all of the files are available for Patreon supporters. So if you support the channel, link in the video description, you get every single file that we do on this channel for free. So consider supporting. Anyway, so let's begin. All right, chapter 1. So one thing before we begin, or two things. First one is this course will be aimed, I will try to tailor this course with an assumption that you're a beginner user, right, of Unreal Engine, somewhat of a beginner user for Unreal Engine. So for those of you who are intermediate users, bottom right corner of the screen, you will see the playback speed of this video. You can increase it so that it's doesn't get too boring for you when I'm explaining simple stuff. Second thing before we begin is installing 2 free plugins, and you can get them just from here, from the marketplace. One is going to be called Easy File Dialog. Easy File Dialog. That one. Just click on Install to Engine and then you're good to go. It might ask you to purchase it for $0, so you just do that and then install it. Either way, they're free, so it's fine. And the second one is something audio runtime. Runtime audio importer, meta sounds. Runtime audio importer, meta sound. Install to Engine, this one as well, right? Once you have those 2 done, then we go to library, we click on launch, and then we can simply create a new file, a completely new file that is going to be called, well, the name of it is just going to be ArchViz YouTube or something like that. There we go. And ray tracing, I will have this turned on because I like pretty shadows, and it's going to be a 3rd-person map. Hit create. Once it's done, then we continue. All right, so once you have this loaded in, you just click play here in the top, the green little arrow, and you run around to see if everything works. If everything works, great, we can move on. If something doesn't work, then well, check it out. I have no idea what kind of error you're getting. You need to fix it yourselves. If you don't see the content browser as well as environment light mixer, then you can just click on this content drawer icon right here in the bottom left corner. And then in the top right corner of this content drawer, you can click on dock and layout, which will basically just, come on. Yeah, it's going to give you a pop-up of this content browser, like so, and then you can just drag it down to properly dock it. All right, with that done, now we need one more thing to enable plugins before we start working. So those plugins that we installed, they are not enabled. So I'm going to go to settings here in the top right corner. I'll choose plugins. And here I'll type in easy file dialog, this one, tick mark. Immediately asks me to, oh, you don't see it. Oh. Immediately asks me to restart. I will not be restarting just yet because there's one more plugin that I want to run, and it's runtime audio something. Runtime audio importer with meta sound support. Very nice. Tick mark that one, and then we restart. So I'm going to right click in my content, third person, maps folder. I'm going to create a new map. So I'm going to right click and choose, or level, sorry, and choose level right here. I'm going to name my level audio viz, audio visualization, and double click on that level to open it up. It's going to ask me, do I want to save it? Yes, I do. And now it gets opened up. Also, what I'm going to do is make it so that every time I run the project, this level is the main one that loads in. So I'll go to settings, project settings, maps and modes, and here editor startup map as well as game default map. I will change both of these to my audio viz level. There we go. Perfect. With that done, now we have a completely empty space, right? There's absolutely nothing here. You can see no objects, no lights, no nothing. So we can start fresh. So in my, I'll expand this. The first thing that we do in this chapter is create the little menu icon that is going to be shown as we start the game. If I now start the game here, my character just spawns and just keeps falling, right? Until, well, forever, I guess. Unless there's a kill volume, kill depth in this level. I don't think there is though. Anyway, so what we want to do is we want to now create this menu icon, menu box, right? In my content folder, I will create a new folder, right click, new folder, and I'll call it widgets or menus if you want to. I prefer to call it widgets. Double click on that, right click inside of this folder and create a new widget, which is under user interface, widget blueprint, like that, user widget, like that, and just name it menu. I did a menu, there we go. So we just name it that way. To edit it, all you need to do is just double click on it, opens up a new tab, and now you can, if you're a new user, you can get kind of confused as to, oh, okay, where's the level again? How do I get back to the level? All you need to do is just take this tab right here that says menu, drag it out, click and drag on it, right? And then you can dock it right next to your AudioViz tab right here, right? So I'm docking it right here. And now I can toggle between these two quite easily, right? This is what I always do. I have everything just docked in one line, and then I can access it from my main window, I guess. Anyway, in here, you can create anything you want. So for example, or rather, example is going to be once we actually have the proper setup. So let's do the proper setup first. So what we want to do is we want to go to the panel tab here. This is, by the way, everything, all different things that you can create in the menu. But the base one is always the same. It's called canvas panel. And we just drag and drop it in on this screen, right? So the canvas panel is basically just a border of the screen and according to it, different objects will be placed according to the the edges, I guess, of this canvas panel, right? So that's always the first thing that you drop, unless you know what you're doing, but I will assume that you don't. So that's the first thing that you that you actually need to drop in. I'm going to grab a text button here. By the way, you can search in the palette for whatever you want. So I'll just type in text, just slap it in there. And for the text block here on the right hand side, you can see there's a menu entry where you can change, the actual text that's displayed. So for this text block, I'm just going to write testing, right? Testing, just like that. I'll hit compile, save, and I have my menu that just has a single text. The problem is that if you just play this level now, well, it's not there, right? It doesn't show up, and there's no button that I can press to make it show up. So how do you make a menu show up? Well, that can be driven either by the character or by the level itself. So we will be activating it when you start the game, when you start playing it. We will be activating and we will be showing it on the screen. So how do you do that? Well, you need to go to the level blueprint. Blueprint is scripting. Basically, you need to script it into the level. And the way you do it is actually pretty simple. Don't be scared. You go here to list of blueprints that are available, and you don't have many. So you do have the level blueprint. You click on that, and it opens up this scary, well, right now it's not that scary because it's empty, but it opens up this blueprint. And you can see that now we have 3 tabs. I have my level tab, I have my user interface tab, and I have my blueprint, my level blueprint tab. So this controls the behavior of the whole level, right? It's much kind of generalized. You can also have smaller blueprints that we will have that are much more localized, but this one is general. I guess that should kind of make sense. And it has 2 events that trigger information, right? That trigger a script flow. So first one is event begin play, which kind of is self-explanatory. When you start the game, something happens, right? And it starts running a certain command, and it runs it one time. And the second one is event tick. Event tick is basically the moment you start the game at every, okay, for the sake of, to make it easier to understand, at every frame of the game, so right, 30 frames per second or whatever, at every frame, it fires off a trigger, right? So this keeps going throughout the whole play session. This happens multiple times, throughout the game. While this one happens only once at the start of the game. What we want is, of course, for it to happen once, the menu. You show the menu and it just kind of stays there, right? So let's use event begin play for now. Later we'll make it a little bit nicer, but for now let's just do event begin play. One thing that I did without really thinking about is I compiled and saved automatically because I'm quite used to it. So back in the menu, if you change anything, right? Let me just kind of drag the text around. You can see that there is this question mark next to the compile button. Compile means that it checks for any errors and it creates a logic, a small little app, if you will, inside of your much larger program. So every time you make any changes, you need to recompile your blueprints, and the menu as well as the level blueprint are both blueprints. So I click on compile, I click save. Now we're good to go. Make sure that compile has a tick mark here. Back in our audio visualization blueprint, like our level blueprint, I will start creating the logic, for showing the menu. First thing first is we need to fetch the widget, the menu widget, We need to kind of just fetch it out of the files and create one when the game begins, right? So what we're going to do is we're going to drag out a wire from this event begin play, and we'll say create audio, create widget. It should be just create widget. Yeah, there we go. Create widget. There we go. And then it's going to ask us, okay, what's the class of the widget? The class is the name of your menu. And in this case, the name is menu. Well, that's what you've written, right, as the name. So here I'll just expand it and I'll type in menu to find it. There it is. Perfect. And owning player, who owns this widget? Well, you're the only player who's going to be playing it, right? So you're going to be owning it. So you can just get player controller and use that, right? I can compile and save and click the play button. And here you will see that, well, actually there's no menu. What gives? You know, there's no testing sign on my screen when I press play. Why? Well, that's because you have created the widget, but you're not showing the widget, right? So what you want to do also is add, you drag off from the output here, release the mouse button, and you type in add to viewport. Add to viewport, like that. It's going to ask you, okay, what should I add to viewport? And that's your widget that was created, like that. The return value is basically after it creates the widget, it spits it out through here, right? Through the output here, and then add to viewport input can read that output and show it, right? Now if I hit compile, play, there it is, our little menu, right? Well, it's not a menu, it's just text. But now you know how to just push any text on your screen, which is nice, because you can now, you know, if you're an architect, you can write, you know, like WASD to move around for your clients and so on. Anyway, that's besides the point. Now, in the menu, let's get rid of the text for now. Don't need it. So the first thing is we create a button. And to get a button, just type in button. Get that? Drag it in. There's your button. And you can rename it as well. I'll just name it import audio button. To rename, it's F2 when you select anything in the hierarchy tab, I guess. It's F2. And then inside of that button, let's add a text. So I'll just select text and drag it onto my import audio button, like that. And you can see if I zoom in here, now I have my little text block right on the button. And if I select the button itself and move it around, the text moves with it. It's a little bit ugly, so I'll just make it a bit bigger. There we go, something like that. For the text, I will change the text itself to import audio, or pick a song, I guess, would be nicer. A little bit more human. Pick a song. There we go. And then for the button itself, I will just change the color and opacity of it. So the opacity should be the hello. Oh, that's the wrong one. Background color, I'm sorry. Alpha, I'll just drop it down a bit. Just something like that. Compile, save, play. There we go. There's our button. Now if I press it, nothing happens, but at least we have it, right? Now let's always position it so that it's kind of anchored to this corner and it's always at an offset from this corner. To do so, you just select the button here in the hierarchy. And if you scroll up, you can see anchors tab. If I open up this subtab, this menu box. Here I can see that I can anchor to the bottom right corner of my canvas panel, right here. I click on that, and now my position is offset from this point right here, right? So if I write my position X is actually 0, then it's like so. If position Y is 0, it's like so, right? So what I want to do is I want my position X to be, let's say 100. Well, let's do 250. And my Y position, I'll do like 300. Oops, sorry, minus 300. Like that. Compile, play. Now you will see that doesn't matter how I transform this screen, it always offsets properly. It's a little bit too far out from the bottom, so I'm going to change it right now to minus 250. I think that's gonna look nicer. It's a little bit too far out, isn't it? 150 minus 125. There we go. Okay, that's much more decent. All right, so we have ourselves a button. Now let's make it do something. Remember how we had the blueprint here, you know, with the chain of events of what's happening once we have the event begin play? Your menu, your widget also has a blueprint that happens when you press things and when the game starts and so on. And that blueprint can be accessed through this icon right here. So here we have the designer for the actual, you know, menu icons and so on, and colors and whatnot. And here we have the graph. The graph is, you know, event construct, event tick, you know tick already, event pre-construct and so on, right? We will not be using, well, we will be using event tick, but that's going to be later. I will just be deleting everything for now so that, you know, we're on the same page, so that it's clean. I'll come back to the designer tab real quick. I'll select my button, not the text, the button itself. I'll scroll down in the menu, in the details tab, and I'll choose from one of these events: on clicked, on released, on clicked, on pressed, on released, on hovered, on unhovered. Things that you can do with a button, right? So in our case, when you click a button, something should happen. So on clicked, I will click on this plus sign. Boop. Immediately gets me into the node editing portion of the menu widget, and also gives me this event that, okay, when you click the button, something happens. Right. What should happen when I click the button? Well, the first thing is, give me a second. I'm thinking. The first thing is, when you click the button, it should open up the browser, right? Your file explorer, so that you can choose the song, right? So what we want is, we want to drag out from here and type in open file dialog. Open file, and this is from Easy File Dialog plugin, by the way. Open file dialog. Right. You can choose to use like a specific file type, like .mp3 here, and it's going to filter out everything that is not .mp3, but I will not. I will just keep it dirty, right? So we have it like that. Right, so now technically, let's compile and play, pick a song, bam, opens up a browser where we can choose a song and hit open. It doesn't do anything, but you know, at least we can select a song now. Okay, that works. Next. By the way, you should think about these wires that come from these white triangles as electricity that feeds the nodes that are connecting to it, right? So if I show you the level blueprint, event begin play, bzzz, electricity, turns on this, create menu widget, which, you know, creates a widget. It goes through it, then goes here, bzz, and it adds the widget to the viewport, right? So it's all chained and it all goes in the correct order, one after the other. So in menu, you click the button, bzz, open file dialog, right? It opens it up. And then if it cannot open, okay, so it gives you three outputs. One is the file that was opened, a file name that was opened. Second one is it couldn't open something, or you didn't choose anything, you canceled, right? So if you cancel, then it should do nothing. If this is false, you should do nothing. If this is true, the chain of events should continue and it should actually play the song, right? So, sorry, I'm just thinking real fast. So what we will need is a logic gate. That's, well, it's not a gate, but it's a branch. It's flow control gate, branch. And I'll connect true or false statements. You know, yes, a file was selected. No, a file wasn't selected. If it's a yes, then it continues. If it's a no, then nothing happens. So if it continues, if it's a yes, then we should create a runtime. Just create runtime audio importer. That's the other plugin that we installed. And with this audio importer, we should import audio from file. Bam. Okay. Who should import audio from file? The audio importer that we just literally created, like that. What's the file path? Well, it's the file that we have selected. The problem is that here you can see from the icon, this is an array, which is basically a list of things. While this is, it just wants a single file. It can't import multiple files, right? Well, this one, you can select multiple files and then it's gonna freak out. So what we want to do is we just want to get first one. You know, if you just selected one, the first one will be the correct one. If you select multiple, it's just going to give you the first song out of the list. So I'm just going to drag out from there and type in get a copy, and connect that to file path. For the audio format, determine format automatically. Yeah, we just determine it automatically. That's gonna be fine. Okay, so now, technically if I compile, save and play, and pick a song, and I pick a song and hit open, technically now the song is inside of the Unreal Engine. We don't hear it, it's not playing. You need to actually play it to hear it, just like with the viewport. Adding to the viewport, you need to add the widget to the viewport, but it's there. So now we need to, need to think real quick. What we want to do is we want to then, if a song is playing, it should trigger, or if a song was selected, it should trigger a separate event, right? That just goes, oh, okay, yeah, I'm onto it, right? So I'm going to drag out from here, from the audio importer. I'm going to drag out the wire from here, and I'll say to on result. Assign or bind? Assign. Yeah, assign to on result. And this one is a little bit trickier to explain, but basically, I'll just connect here. If there is a result from here, this feeds back the electricity into this event, and this event triggers, right? So I can just say song selected event, or the name doesn't matter of this, so I'm not going to explain how to do it, but it's basically song selected and then it plays, right? So don't forget this wire though, because bind event needs to also electricity to work, right? So when you select the song, there should be a little bit of a delay for the machine to catch up, and also just for it not to blast immediately as you press play. So I just drag out, here I type in delay, and I'll say, let's do like a 1 second delay, 2 second delays, two seconds, right? And when it is completed, we should check the status of, we should check the status of the importer if the audio file has been imported. So the status can be, this is not going to be true or false, this is going to be multiple values. So I'll just drag out from there and I'll write equal enum, like that. Not operator is equal, but equal in enum, enumerator. And here I'll expand. Oh, okay, so it has like options of success, failed to read, sound wave declaration error, invalid audio format, audio does not exist, load file to array error, right? So only when it says success should it continue on. If it's anything else, it should freak out and it should stop working. So here we already have this logic, branch. If yes, then play. If no, then stop. So we're going to do the same thing. I'm just going to create a branch, just like that. It's nerdy stuff, I know, but soon we will get to the fun stuff with the materials. That's chapter 2, but you need a menu for, you need chapter 1 to do chapter 2. I'm sorry, it's boring, I know. Bear with me. Connect, like that, right? So now, if this is a success, true will fire off. If this is false, if this is not a success, anything else, then false will fire off. If false fires off, I kind of want to see what the fuck is going. I swear, I'm sorry. I kind of want to see what the hell is going on. So I'm going to say, if it's false, then print string, print something on the screen. And the string should be the status. So I'm just going to connect the wire from status to string like that. It creates a node in between enum to string. I'll just kind of position it like so. Okay, we're good. So if it fails, it tells us why. If it's true, if it doesn't fail, if it's a success, then it fires off here. When it fires off here, I want it to play, but I don't want the menu to take care of the playing. I want a separate blueprint to actually do the playing of the song part, because then in that blueprint we can also analyze it. Rule of thumb is you don't want your menus to be too heavy in terms of blueprints, in terms of calculation, right? So all of the analysis and so on will be done in a separate blueprint. Right, so for now, I will just compile and save this, and I will create that so-called separate blueprint. In my level, I will go to my content folder, right-click and choose new folder, and call it blueprints. Blueprints. Double-click on it. Yay. And inside of this blueprints folder, I'll create a blueprint. Right-click, a script. Blueprints are scripts, basically. Right-click, choose blueprint class, actor, the first one, and I'll just name it listen. We can do like listen BP so that it's clear that it's a blueprint. Listen BP, F2 to rename things. Listen BP, that should be good enough. I mean, yeah, that's gonna be fine. So in listen BP, what we want to do is we want to trigger an event. Oh, sorry, let's open it up first. So this is our listen blueprint. We immediately go to the event graph rather than the viewport because we care about the logic. I'll delete everything in here. We don't care about those nodes. We will make our own. And in this event graph, what I want to do is I want to create a custom event, add custom event. I'll name it play evaluation, play event, play EV. There we go. Play EV. That's gonna be good enough. Play EV. This play EV will trigger from our menu, right? So when this is true, it should fire off and it should trigger our play EV. But also, when this triggers, it should create sound. Create sound 2D, like that. And the sound that it should create is going to be an imported music, imported wave file. So I will say that, well, we can't select it from the menu of files that we have imported into Unreal Engine because it gets imported during the game time, right? So this needs to be a variable that changes over time, right? That changes accordingly to what you have selected. I'm going to right click on this. I'll choose promote to variable. I think that can change. And it's annoying, but here it is, right? Here's the node. And basically this is an empty container in which like anything can be placed as long as it's a audio file or raw audio file. So I want to rename it from sound to wave sound, or actually sound sounds fine. So let's keep it as sound. Right, so two things. Play event and sound. Compile, save. Don't forget to compile and save your listen blueprint and go back to your menu widget. Here, when it's true, it should send over the fetched audio file, the imported audio file. It should send over to the listen blueprint, and also it should trigger the event that listen blueprint should play the audio file. Okay, this is gonna be, actually it's not gonna be that bad because we only have one listen blueprint, so it's fine. So let's do it this way. We drag out from branch, true statement here, and we get all actors of class, like that. And for our class is literally the name of the actor, listen BP, right? So I'll expand this and type in listen BP. Yay, it caught it, right? So now basically if you have this blueprint in your map used, then it's going to fetch it. The problem is that if you have 25,000 copies of your listen blueprint just copied all around the map, it's going to fetch every single one of those, right? And because of that, the output of this is always a list. The list is easy to deal with because we know that we will be using only one actor, right? So we just get the first one, right? Get a copy. Bam. And that's going to be always the one that we want, right? Because a list of one, you get the first one from the list of one, that's the one, right? With that done, now we have the possibility to set, drag out from here, set wave why I can't see it? Oh, that's not wave, set sound. Set sound. There we go. There it is. Cat, come on. Set sound. Bam. And now, if I compile this, from this blueprint, oh, don't forget the electricity, bam, to make this work. Oh, cat, don't stop. I have a new cat. His name is Momo. I can show you. There he is. And Momo loves to sleep on my keyboard when I try to record a video. Anyway, moving on. So set now triggers and overrides this variable with anything that you plug in to here. So now we need to fish out where the hell is our wave file, where the hell is our imported sound. And it's all the way here. This custom event that triggers from this import audio from file also has an output of the actual wave file, imported sound wave that was imported. So what we will need to do is drag a really long ass wire, and it's gonna be annoying for the tutorial, but it is what it is. Imported sound wave from here connects to sound in here. Yoink, just like that. Now, technically, if I compile, save, oh no, never mind. Well, I can show you. If I compile, save, and press play, I pick a song, I choose a song, I hit open, nothing happens. Why? Well, that's because access none. 1 second. Why is it none? We'll figure it out later. Probably not an issue. Famous last words. Anyway, so for now, this does not work yet because we are not triggering this event, right? So it never plays. So what we want to do is we want to play with this. And to do that, we will, from this get, drag out one more. And how was it called? Play EV. Type in play EV, and that is the function that we will call play EV. Electricity comes in, bam. And now it should work. I think, yeah, there's no way that it's not gonna work, right? Compile, save, play. Please. Okay, it doesn't work. Escape out of that. Okay, it is really not happy with me. Saying set sound, execute Ubergraph menu blueprint, event. I made a mistake somewhere. Let's see. So if we go to the level, you actually, I mean, I don't have anything in the level, right? This just exists. Listen blueprint just exists as a file in my system, but it's not used in the level. So of course it won't work. What I need to do is just drag it into the freaking level for it to work. So you drag it in, right? Then you press play, then you pick a song, you choose the song, you hit open. The typical, we create the sound, we don't play it, we just created it, right? So after, this is in listen blueprint, after you create a sound, you drag out from here, and you will choose start analyzing output, because that's anyway what we will need to do, start analyzing output. Don't expand it, it's scary, just minimize it, you're good to go. Like that, and then you press, you drag out from there and you type in play. Scroll. It should be easier. Play manager, set play rate, play dialogue, play sound 2D. I don't like that. Can I just do? Can I just drag from here? From return value, I'll just drag out from here and type in play. Should be better. Yeah, there we go. Play. Bam. Electricity, don't forget. Something like that. So analyzing, by the way, if we expand it, I probably should show you. There are like different ways of how you can analyze the the sound, but I honestly would suggest not dealing with that right now, and just using the default values. Yeah. Anyway, compile, save, play. Play. Pick a song. There we go. Okay, good. Good. So now there are issues that we need to fix, and once we fix them, then we will move on to chapter 2. Yay, finally. So issue number 1, easy. If I press play and I click anywhere else than the pick a song, my mouse is gone. I can't select pick a song anymore because I'm in play with the character mode. No bueno. Issue number 2, I don't really want the menu to be always there, right? So I want to fix that. We will fix both of the issues at the same time. So let's go ahead and then do that. So if I go to my map or to my level blueprint, audio visualization, expand blueprints here, open level blueprint, bam. If I go to the blueprint here, I don't want it to spawn when event begin play begins, right? So I will delete that. And instead I want to spawn it to spawn when I press the M button. Right click, key event, and just choose any key from that has this icon. Doesn't matter which key you choose. I'll show you why, right? So you choose it, select this node, go to top right corner, input key, click on this little keyboard here, and then press the M button. M for music, M for menu. Right, once you did that, now every time you press M, this is going to fire off. Sometimes you also need, if it doesn't work on your character or on some other blueprint, then you would need to do this. I'll show you real quick. Event begin play, enable input, target self, player controller, get player controller. Yeah. So if for some reason this does not register, then you need to do, you need to enable input. It's an optimization that basically not every blueprint is able to receive input from the keyboard, and thus it's better to tell which blueprints are able to receive input than all of them being able to receive input, right? In this case, this is a level blueprint, so it doesn't matter as much. I just wanted to give you a heads up if you're gonna be customizing it. Anyway, for pressed, the first time I press it, I want the menu to pop in, right? So, and then second time I press M, I want the menu to disappear. So pressed will have a flip-flop logic to it. First time you press it, A fires off. Second time you press it, B fires off. Third time A, fourth time B, blah, 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 right? Should be pretty straightforward. So first time I press it, it should create menu widget like that, easy. But also after adding, I'll just get it here. After adding the menu widget to the blueprint, it should show the mouse, right? So for that, I will need to get player controller. I'll already have the player controller. I'll drag out from it and I'll say set mouse visible. No, set mouse cursor. Yeah, set show mouse cursor. There we go. This is the one. Set show mouse cursor. And I'll tick mark that. And electricity, don't forget. Bam. So when I press M, it shows me the menu and it shows me the mouse. And also, it should not move the character anymore around as I am in the menu. So I'll expand from here and I'll set input mode game and UI, just like that. Player controller should be, you just double click on the wire, by the way, to be able to branch off from the wire, just makes things cleaner. So player controller, get player controller, same thing. In widget to focus on, you could just use the, where is it? This widget right here, if you want to. I will, yeah, I'll just use it like that. It's a little bit, could be cleaner. Let me try and clean things up as much as possible, but yeah, this is the best I can do. In mouse lock mode, do not lock, hide cursor during capture. Oh, who cares? Actually, don't hide because I want you to see the cursor. Okay. Okay, so that should be good. Compile, save, play. Nothing here. I can move the mouse around to rotate. I press M, immediately mouse pops in. I can pick a song and so on, and everything's great. Right, escape to cancel. Right, so now when I press M again, the menu should stop being there. So I will say if output B from the flip-flop, remove from parent. Huh, that's interesting. That's not there. Let's drag out from the menu widget itself, like that. Remove from parent. There we go. That's the one. So create menu widget. I just drag out one more wire, remove from parent, and now I will connect B to, the electricity zip, and this one now works. Let's make it cleaner. Actually, I don't need a wire there. I can just grab one from here like that. It's a little bit yucky, but should be fine. Okay, remove from parent. Then I'll just get another, get player controller. I don't want to just kind of use long wires here. So I'm just getting another one. Set mouse cursor. Set show mouse cursor. Bam. We turn off the mouse. So this is not tick marked while this one is ticked. And we also change the input mode. Set input mode game only. Player controller, get player controller. Easy peasy. All right, compile, save, play. M, mouse there, M, no mouse, M, mouse there, M, no mouse, M, mouse there. Yeah, perfect. Okay, one last thing before we move on. If I press play, M, mouse there, pick a song, I choose a song, pop. And now I need to press M again to get out of the menu, but I've already selected the song. The menu should disappear automatically, right? Right? So I want to not need to turn off the menu manually. When I select the song, it should turn off automatically. And we can take care of that in our menu widget right here. Because we already have, okay, it fired off, means we have managed to select a song. So now all I need to do is just specify that it should be removed from parent. Target is self, right? The widget itself should be removed from the viewport. And then we should get player controller, set show mouse cursor, it shouldn't be shown, and set input mode UI, or sorry, game only. Bam, like that. Compile, save, play. M, pick a song, choose a song, hit open. There we go. When it starts playing, it lets you, it turns off this again. The lag was because of this delay of 2 seconds. I think 2 seconds is too long, so we will just do 1 second instead. Compile, save, play again, try, pick a song, good, there we go. Yep, 1 second, and then we're back in the game. Nice, so now we are able to import any song. Next chapter is going to be us being able to read from the imported song, right? Read out the values. So we'll be printing out a few things on the screen. Right, chapter 2. All right, chapter 2. So now let's make geometry or materials interact with or react to the audio that we import. So the first step is actually to have some sort of an environment in which we can, actually place our character. And if I press play now, it's very lonely there. So I will be creating 3 things. First thing is going to be just a plane on which the character can land, so that it's not just falling all the time. So I'll go here to the top left corner menu, quickly add to viewport button, go to go to shapes and add a plane. Bam, just like that. And for the plane here, I will, you don't see it, pop, there's the menu. I'll log the scale right here, and I'll type in like 100 in terms of the scale, right? And then make sure that the location, let's just set it all to 0, right? Location is all 0, 0, 0, scale is 100. With that done, now if I press play, the character still falls because it spawns. Yeah, okay, so we need to actually, I really want to create a light source, but I know that this is going to suck if I do. So I'm going to change instead from here, instead of lit, I'm going to choose unlit, like that. Then as I look around, I can see where the plane is. If you can't see it still, you can just select the plane, like that, in the right-hand side menu, and hit F button, F to focus. And now your viewport will focus in on the object that you have selected. Then with WASD, while holding the right mouse button, you can kind of navigate to it. If you're too slow, the camera move speed is here. So you click on it, increase the speed to, let's say, 16. Let's do 8. Zoop, and then now we're zooming. Okay. And as long as you have changed from lit to unlit, it should just show the color of the plane itself without any light. So since the plane is white, it shows white. That's all we need, all right? Then for this, I will also create a basic player start position. Bam, like that. And I will just zero it out, 0, 0, 0, and just move it up a little bit. Let's see. There he is. That's not a little bit, so I'll just say in the z-axis it should be like 100, so a meter above the plane. Okay. If I press play now, you can see that it's now standing on the plane. It's still pitch black, and the only light source is the little logo on the chest of the character, but it's at least, has a plane to stand on. Then I will create a point light. Let's create a, how do you call it? Spotlight. Let's create a spotlight. So here under the quickly add to the project, I'll go to lights and I'll choose spotlight. You can also add rectangular light if you want to. Actually, let's add a rectangular light. Why do we need to deal with spotlights? Rectangular light, bam, it is what it is. Then we just simply, actually I'll zero it out as well. F to zoom in. Now the camera is way too fast. There we go. Move it up. And now we can actually change from unlit back to lit to see what's going on. Like that. that's where the character will be looking at when it spawns. So I will just move it around. By the way, if you don't see the movement arrows, move, rotate, and scale icons are here. So I can choose rotate, can rotate it. Or if you just select the object and you click on W, that's move, E is rotate, R is scale. That also works, right? Okay, let me press play. There we go. You know, some sort of an environment. If I hit M, then I can pick a song. And I can just run around with some nice music. Okay. You will hate the song by the end of this video, by the way. or maybe you don't really hear it. I have no idea. I have no way to... I can only see the graph. It doesn't matter. Okay, so we have this basic setup. And the last thing is our listen blueprint that I select here. I'll also zero it out. So it's somewhere here. I kind of want it to be positioned actually right below the light, somewhere here. Perfect. So now what I want, this is going to be like middle of the chapter. In the middle of the chapter, we will have 4 boxes that react to the sound, right? So that's what we're doing. I will go into this listen blueprint, and here I'll start creating some script, a script, right? So first of all, how often do we evaluate? How often, by the way, I'm in the event graph. How often do we evaluate the music that's playing? You know, how often do we update the value that we evaluate? That's going to be every chance we get. And that is exactly what event tick does. Just ticks as often as it can, right? Event tick. So this is going to fire off impulses like crazy, and we will just get magnitude from or for frequencies, right? Because here we're analyzing the output like so, and here we're getting the magnitude for the analyzed music, right? And the frequencies, you can see that it asks you for a list. Again, this is a single value icon. This is a list icon or array. So what I need to do is I need to make an array. Make array. And here I can add like a frequency that I want to analyze. I can add multiple, but for now we'll just do one. So let's say, what's a good, like 200 hertz frequency. And we will be kind of cutting through the song at that particular band, and we'll see how strong the sound is at that particular frequency. And then from the magnitudes, since this is only one, I can just say get a copy. I can just get one, right? And then I can print it. Print string. And notice that when I say print it, since this is a number, it immediately goes like, oh, you don't want to print a word. This is basically defining how long the word that's printed on the screen should stay for, right? So it automatically connects to duration rather than the string. No. You disconnect with the control key, drag backwards to disconnect, and you drag it into the in string input, like so. It automatically converts it to text or to string in this case. And then don't forget the electricity. And this is going to be firing off like crazy the moment we start playing the game, right? Again, very heavy for the computation, but necessary in this case. Press play. 0, you know, it's completely silent. Because of that, it's 0. But if I pick a song, the good song, updates. Great. Okay, escape out of that. So now we have a value that changes. I want to make a box dance according to that value. And then I will want to make 4 boxes dance. So let me save that. So to do so, I will just, yeah, we need a box. So I'll go to the viewport tab here and I'll add a cube. Bam. Just a cube. And then for the cube, well, actually, basic shape material, sure. We just use default material, that's fine. So we have a cube here. Then back in the event graph, I can grab the cube, easy, bam. And I can set world transform. Set relative transform, not world. Well, it actually doesn't matter because it's just, yeah, set world transform, whatever. Do we need a transform though? Sorry, give me a second. We can make it shake, but let's make it scale instead. So we don't need a transform. Set world scale 3D instead. Set world scale 3D. And I'll just connect the electricity from my so we're printing the value, and we will also be using the same value to scale the cube in the Z direction, which means the X and Y directions should be 1. You know, the scale of them should be 1, while the Z is going to be jumping around. So we need to drag out from new scale, make vector. Make vector. It's right in the, oh, sorry, again. Make vector, right there. Now we can add multiple values. And this one only connects to the Z input. And X is 1 and Y is 1. So now at every tick, it takes that cube that we have here and it updates its scale according to the strength of the sound at 200 frequency, like yeah, you get what I mean. Play. The cube is, oh yeah, right, I forgot, sorry. I'll go back to audio visualization, and here the cube is just there. Actually, that's pretty cool. I'll keep it there. So the cube is kind of intersecting with the ground. Don't worry about it. Let's just play. I play, the cube is right there. Huh. Okay, it didn't crash, but damn, it didn't like the collisions. Right, let's not do that again, and let's save all, and then do it again. Play, pick a song, anywhere you go. And there's our cube. I just want to jump on it real bad. Come on, just, yep. Nah, it just clips through. So you can see, wait, this is very loud. So you can see how jittery this is, and it's gonna be a problem, right? But before we solve this problem, there's another thing that we need to solve, and that is how do you do it for multiple cubes, right? Because, oops, wrong blueprint. Because right now we only have 1 cube, right? But what if I want to show 4 bands or 6 bands or 12 bands? Well, first of all, we need then 4 or 6 or 12 cubes. So I'm gonna make some copies of this. Holding down the Alt key, I think, nope. Control C, Control V, copy paste. And I guess I just paste them from left to right along the X direction. So that's 1, Control C, Control V. That's 2, Control C, Control V. That's 3. There we go. And then I just select all 3 of them. Come on, all 4 of them, sorry. and I just move them so that they are around, they're located around the middle point. Somewhere there. Up. Good enough. Okay, let me also move them up. Yoink. And now we're Gucci. Okay. If I now check the map, this is how it looks like. I really want to rotate this though and move it in the back a bit. Play. Yeah, that seems okay. Right, so now with the 4 boxes, I want to transform those 4 boxes at 4 different bands. So first of all, we need a list of 4 items, not one item, or not one item. So I will add pin right here, and I'll do it 2 more times. So the first band that we analyze is going to be like 50, second one can be 200, third one can be 400, and fourth one will be 1,000. Okay. So now this is going to change a little bit, right? And let me just delete everything after get magnitude for frequencies, because suddenly we're dealing with a list of things. We can't just get. Well, technically we can, but it's going to be a little bit of a iffy. Not as nice. So instead we're going to make it a little bit nicer, a little bit more elegant. Delete. Get magnitude for frequencies. We have a list that keeps updating, right? So what we do is for each, drag out from magnitudes and type in for each loop. For each of these magnitudes, oh, it automatically executes as well. That's cute. What's that? No, never mind. For each of these magnitudes, as they are updating, right? Or rather, these are frequencies, and then we get magnitudes of these frequencies. As they are updating, it's going to go through them, pop, 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 one by one again, at every tick, right? So we will then need to, one second, thinking, still thinking, need to think, still thinking, still thinking. No, it needs to be other way around, right? Yeah, it needs to be other way around. We will be using for each loop, but we will not be using it on the magnitudes. Instead, we will be using it on the cubes, the array, the list of cubes. So what we need to do first is create a list of cubes that we have. Easy. We just drag in cube 1. You can shift and drag multiple. We have these 4 cubes, and I will just drag out from the first one and type in make array. Make array. There we go. Add pin. Cube 1, cube 2, cube 3. Make sure that they are, in the proper order, or else your bands will be out of whack. And then for this array, we will say for each cube, just go through them and do the for each loop. For each loop. Execute like that for each loop. And in the loop body, we will say, well, set relative or set world scale, set relative scale 3D. And it's gonna ask you, okay, what's the target? Well, the target is going to be the array element. As it's going through the list of 4 cubes, it's going to pick the correct one, as the target. And for the new scale 3D, we will right click, promote to, not right click. We will make a vector. We will just make a vector out of these 3 values. X will always be 1, Y will always be 1, Z is going to be the tricky one. Okay, now how do we get from these magnitudes a correct XYZ a correct value. From this list, how do we get the correct item that matches up with the list that we have here, right? So that cube 1 or just cube gets the values from band 50, cube 1, band 200, cube 2, band 400, cube 3, band 1000. Well, we get item, or not get item, get a copy from these magnitudes. And then here, notice that as it's going through the cubes, from the first one to the last one, it also gives you array index. So it tells you which cube it's currently looking at. Well, we can use that to get the appropriate band or the appropriate magnitude. And then we just simply connect it to the Z. And that's all. It's a little bit wiry. I will be cleaning this up, but this should work. So let's just compile, save, play. Right now, nothing's playing, right? So all of them are like just flat because it's all 0. But if I pick a song, yeah, there we go. We have a jittery, super jittery interaction, right? It is reacting to the sound. All right, now this is like the middle of this chapter, as you can see in the timeline, right? Hopefully it's the middle, fingers crossed. Next step is going to make those values softer so that they don't pulsate like freaking crazy, right? So yeah, this is going to be the second part of the chapter, and then third part of the chapter is going to be the material, creating the material. It's going to be fun because the material will look cool. You saw in the start of the video, yeah, you saw it. So when it comes down to softening the values, actually there are multiple ways of how to do it, and I'm going to try to teach you one that's a little bit simpler to understand but might not be the most optimal. But for beginners as well as honestly intermediate users, this should be definitely good enough. So first of all, let's somewhat disconnect the cube manipulation part from the get magnitudes for frequencies. Using Control key, hold it down, disconnect the wires, just like that. And let's just move down this whole portion of the script so that it's not in the way. We will fix it a little bit later. So the first step is actually after you get the frequencies, right? You want to separate them out into different bands, and then you work with them not as a list but individually with every band, and you soften every band, and then you reassemble them into a softened I don't know how to call it, the smoothed list, smoothed array, right? So we will, for these magnitudes, we will be using, as per usual, for each loop, which basically just goes through, bam, 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 constantly going through these 4 magnitudes and re-updating them at every tick. I should have the tick here. There we go. Okay, so as it's going through them, then it should, well, first of all, the array elements, if you check power of 0.3 crap. 1 second, bear with me. Bam, bam, graph. No, other way around, abort mission. How do I go here, 0.3, delete that, and then I go here, X, like that, play. Huh? How should graph? Give me a graph. There we go. So The issue is that low frequencies that we have, and can I zoom into this? Where's one? There's one to one. So it ends right here where my mouse is, right? So the issue is that the frequencies that we currently have, they shoot off to the space like crazy, right? And what us raising to the power of 0.3, for instance, does, it makes it not shoot out. It kind of bends down the curve, right? So a very large frequency or very large magnitude gets kind of squished down to, it still goes, I think it goes to infinity. If x is infinite and you raise infinity by 0.3, yeah, it's still infinite, right? It still goes to infinity in terms of the magnitude, but much slower, right? And that's what we want. So we're softening the numbers. We're giving it a soft cap, and it's very easy to do. So for these magnitudes, we use array element, and we just say power, and the exponent of the power is 0.3. That's it. So all of those kind of wacky, very high column looking things, they just kind of get squished down very, very much. This is very useful for anything that goes out of whack. Keep that in mind. Very useful. Even though it's very geeky and I feel dirty saying it. Then, as it's going through these 4 values, we will create a branch asking if the array index is 0 equals equality equals 0. Does it equal 0? If it equals 0, then it should calculate for... Is there a faster way to do this? Maybe, but I don't... No, let's keep it simple. If it's 0, then it should calculate for the first band, and it should soften the first band. If it's false, then it should move on to check if the array index is 1 or not. Hope that makes sense, right? So first of all, and it's going to be a lot of copies, so bear with me. Again, if you just want the script, Patreon supporters get all of this for free, as long as they support the channel, of course. Link in the video description below. So now I am going to say, one second, I'm really quickly thinking. We need to create variables. So I'm going to say, so let's create right here under variables, press the little plus sign, and here we will create a new variable called accumulated value for band 0. What would be a shorter version of it? ACC value 0. ACC value 0. And it's going to be, the flavor of it is going to be a float number, right? It's going to be a float number. And then what we're going to do is we'll go and create one more variable. Bear with me. This is going to be fine. One more variable, and we'll say recorded rec values, multiple values, 0. Again, recorded values. And this is not going to be, we're going to be recording a list of values. So this is not going to be just a single number, it's going to be an array, a list. So here with recorded values, I go into variable type, and here instead of this little dot or dash, I change it to array right here. Make sure that recorded values is selected, right? Okay, now we're cooking. Now we're gonna be good. So with that done, we get this value, right? This is the current value. And we will add it to, we will record it into this array. So recorded values, drag it onto the screen and choose get recorded values, like that. So this is our array, and we will add array add, like that. And this value will be added into the array, but only if branch says that it's true, right? Because we're working with band 0, that the 0 here for recorded values means that it's, we're dealing with the first item. We will have copies of this, accumulated value 1, accumulated value 2, accumulated value 3, as well as recorded values 1, 2, and 3, right? So for now, we have a list onto which we just keep adding in one after the other, the recorded values, right, of the magnitude at band 0. Right, then we will ask if these recorded values, and let me just drag them down a little bit, like so. We will ask how long is the list of us recording these values. So length, array length, we ask for that and we get a number, right? And we will ask, is it smaller, less, is it less than, let's say 5, right? So we keep, at every tick, we keep adding the recorded values, right, into the recorded values list. We keep adding the values of the magnitudes from band 0, and we keep growing that list. And basically, once it reaches 5 or more, this will shoot out false, true. It will shoot out false, right? And if it shoots out false, then what we do is we kick out the first item, right? So it always has 4 items in the list, right? With the fifth one, or the first one being removed constantly and more added, right? So it's a shifting list. We always, in doing so, we will always measure the kind of, in this time frame, the current one as well as the 4 previous evaluated numbers. Oh, I'm doing a great job explaining this. I'm so proud of myself. Okay, we will use a branch for this. And I'll connect the electricity from the add to branch, the trigger, right? And if this is more than 5, so if this turns out false, then we will remove index. Remove index. From where do we remove the index? Well, from the same recorded values list, right? Like so. And let me just make it a little bit nicer. Bam, something like that. Okay, so we're removing the index 0. That's great, from the first item on the list. And if once it's removed, then we're happy. If it hasn't filled up yet, filled in the array yet, then we just continue passing through. That's fine. Okay, then we will use for each loop, we will take the current list that we have, and we will use for each loop on that list. So the array is going to be the same. This is so yucky in terms of wiring, but it is what it is. So that's for the recorded values, right? We're going to be using the same array. And this for each loop should trigger no matter what, no matter if the branch goes true or false. So it should trigger like that. right? Both of the wires trigger this. And then for each loop, we'll, one second, thinking. We'll add this array element will be added to the accumulated value variable. Get accumulated value, drag it in, connect that like so. And that's going to be added. And then also it is going to be set. Accumulated value, we drag it in again, set accumulated value, like that. And loop body sets it. Okay, we're almost there, bear with me. So what happens is you get array of 5 elements, right? In the array, 5 numbers, 10, 15, 20, or I can, wait. Notepad. Array of 5 elements comes in. 5, 12, 6, 1, 2, right? What then this does, and it comes in as a list that constantly keeps changing. What this does for each loop, it goes through every single one of these numbers, right? And it takes an empty container, which is accumulated value, and it adds to that accumulated value container. So what it does, it just goes through them and it adds, okay, 5 plus next loop, or rather plus 5, plus 12, next loop, plus 6, plus 1, plus 2, right? So it just keeps going through the loop for each of the items here. And it just adds them up. So 17, 23, 26. And it, at the end of this, once this is completed, it gives you give me a second, thinking. Once it's completed, it gives you a sum of all of these elements. Maybe there's a faster sum mass addition. Some accumulation, get accumulated time. No. Okay, so it just gets mass addition of all of this. So once it's complete, what we want is we want an average of all of this, right? So we want an average of the current frame or the current kind of evaluation, as well as the 5 that were before it, so that we soften and there's no jittering. So it kind of softly increases or decreases, right? Understand where I'm going with this? So as it's completing, we will divide, once this is completed, the accumulated value, give me a second, I'm still thinking. Yeah, it should just be like that. The accumulated value should be divided by the length of the rectangle values, which is most of the time is going to be 5, but you know, at first like 3 or 4 frames, it's not going to be 5. So we divide by the length of accumulated values array, like that. Boop, just like that. And here the output that we will get is going to be the softened version of band 0, right? Of the magnitudes from band 0. The issue is that we have 4 bands, so we kind of need to do this over and over and over again, and I'll show you how to optimize it a little bit so that it's not so obnoxious. And the way you do it is you just take your variables. Take your variables, the rec value 0 and the accumulated value 0, drag them over to the left hand side, like so. select everything after them. Don't select the branch and like these checks, we will need them to be naked, but select everything else like so, right click and choose collapse to function. It makes this function right here. We will need to clean a few things up inside of the function. It's basically like a group of components that acts as one node. Very, very useful thing, but we need to clean it up quite a bit. So first of all, the inputs, because we have so many yucky, how do I say? We have way too many inputs, and you can see that this connects like 3 times, this connects 2 times. No, let's clean this up. If you select the node, on the right hand side, you see all of its inputs, and I'm just going to remove some of them. So for instance, new item is literally the current value, right? The current value of the array. So I'm just going to say current number. Bam, current number. Then for the recorded values, I'm just going to name it. Instead of target array, we say recorded values, like that. And I don't need other 2 inputs for this. I will just use 1 here. It's going to freak out, don't worry about it. But I just remove other 2 here. And for accumulated value, that's exactly, I do exactly the same thing. Accu value. Like that. But also one more thing that I will do is I will create an output, right? Because what do I want this to spit out? Well, if I double click on it and I look here, remember it gives me a smooth version, a smoothed out value. So if I go back to the event graph by clicking on here, I can select this function and I can choose to add an output by clicking this icon right here and name it smooth number or smooth value. Smooth value. Oh, also B is not required. I'll just delete the B as well. So those are complaining, that's fine. Smooth value asks me what's the flavor and is it a list or not. It's not a list, so it is a single thing. And the flavor of it is going to be float. Float is basically a number with digits after the comma. Okay, we're happy. We're getting there. Now, if also I want to rename my new function to something that is not that. So to do so, I just need to, you double click on it, you get into it, and here where you have the starting node, which says new function, you just give it a new name, and I'll say smooth out a stream of numbers. It's a long one, but it's a correct name for the function. And then notice that return node has been created. Goes back to the end, and here the return node just connects to smooth value. And when should it be triggered? Sorry, the smooth value output connects to the actual smooth value. Smooth value input connects to the smooth value output right here. And when should it be triggered? When the loop ends, when this loop ends. So completed connects to the return node, right? Now it's time to clean things up. So there's a bunch of errors just simply because I have deleted the inputs. So now it doesn't have, you can see it doesn't have connections. Very easy to make connections, you just redraw them, right? So recorded values connects here. Now these two will be happy with it. Then here the accumulation, we don't press those. The adding in to the values, that needs to be a long wire, accumulated value. Or actually, let's just do a node here, like that, and then connect it like so. A little bit cleaner, a little bit nicer. These node, icons or buttons, dots, they don't cost anything, so it's just for cleaning purposes. Accumulated value connects to the addition and just keeps getting accumulated. And then recorded values also needs to connect to the addition here, don't forget. Once you compile, all of the errors will be gone. The only issue that you will have is here it says set accumulated value 0. But what if you connect something that is not accumulated value 0? What if you connect something that is, you know, completely different, right? So you connect to this node, to the smooth out stream node, for the Q value. The variable that you connect is not accumulated value 0, but accumulated value 1. Then suddenly this doesn't work because it still writes into accumulated value 0. You can't use this node in this context. So I will delete it. I will delete this node, and instead I will write, we can just drag out from here, set float. Set float by ref. Sorry, the context, not the context, but the naming skipped my head. It's not set float, it's set by ref. Set by ref value. Set by reference, right? So you reference this instead of specifying which particular variable you want, and the value of it, let's drag all the way to here. Okay, again, accumulated value connects to the target, and then we drag all the way to here, and now the value is, you know, the accumulation. We set it and we keep adding to it, and the loop body connects to the as the trigger. Okay, now we're Gucci. Compile. It's red. Why? Hello. B no longer exists on routes. That's fine, isn't it? This should be fine. Compile there. Oh, I need to disconnect. Okay. Disconnect with control key. You disconnect from the event graph, and now it's happy. All right. Now we're Gucci. Now we're cooking. So now we are going to be getting the smooth values, right here. And what we're going to be doing is we're going to be adding them to the smoothed array. So we're going to be making one more variable. Just click on the plus sign. I missed. Click on the plus sign and call it smoothed array. Let me make this a bit bigger so that you can see. Smoothed array, like that. Drag it in, get smoothed array, add to the array. This triggers it, and the value is this. And that just gets added to the smoothed array. Okay, finally, we're cooking. Now all we need to do is just kind of repeat it 3 times, but it's gonna be copy and pasting, right? So it's not a big deal. All right, so it goes through, it checks if we're at band 0, and it runs this if we are. If we are not, then it should create another branch, like here, and it should check equal. Is it band 1 then? If it's not band 0, is it band 1? And if it is, then it's going to make a smoothed out version of the numbers from band 1. Then if we need to, we create, or not if we need to, but so this is if it's true, we will just copy this. If it's not band 1, then we check. I'm just Control-C, Control-V-ing. We will check if it's band 2. And again, Control-C, Control-V. And if it's not band 2, if it's false again, we will check, is it band 3 then perhaps. Well, it should be band 3 because it's only like 4 of them. So 0, 1, 2, 3, right? So the false will never trigger here. It's going to be true always if everything else fails. All right. So we have that logic. Then I will just simply take this smooth out function, just the function without the variables. I'll connect true to here, Control C, Control V, true to here, and true to here. All right, now the boring stuff, right? Oh, also, I should have just taken these as well because you will be always adding to the smoothed array, right? So let me just delete this and really quickly redo. Control C, Control V. That's the group. Because you're always adding to the smoothed array, right? Whatever smoothed version you get of the 4 bands. This is not sustainable if you need to do, you know, like 100 element analysis at the same time. Like this method is not sustainable. You would need to use more elegant, but more of a black boxy type of a approach. But for 4 bands, this is absolutely fine in my opinion. Okay, we have these values. We can't just simply reuse them. And also don't forget to connect the power output to the current number input for all 3 of these, like that. Okay, so we can't reuse them. We need new ones, you know, for the recorded values for band 1, recorded values for band 2, recorded values for band 3. I will just simply select accumulate or recorded values, Control C, Control V, V, V. I'm just making copies of it. I'll just rename them. So recorded values 1, recorded values 2, recorded values 3. I'll just select one by one, drag them in, get, oh, that's it. Drag it in, get recorded values 2, get recorded values 3, and just simply connect them. Just like that. I'm trying to remember how I used to... doesn't matter. Okay, then I will do the same thing with accumulated values, 2, 3. I copy paste, right? And then 1, accumulated value 1, accumulated value 2, accumulated value 3. Easy. Clunky, but easy. And then I just simply connect them like so. All right. Compile, save, we're Gucci. We're good to go. Now there is an issue, and the issue is called our smoothed array. We will get, 1 second. The issue is called our smoothed array will constantly increase more and more because we're adding more and more and more values at every tick, right? We're just adding and never removing, right? So it's going to be per each tick, our smoothed array will get 4 values. Second tick, 8 values, third tick, 12, 16, 24, or 20, 24, and so on, right? So we need to somehow clear the array, right? So at this point, I will make a sequence. So sequence of events, right? It's going to make it a little bit cleaner, right? This is kind of done. We get a smooth array, but once a single frame calculation is completed, then I will make a sequence. So for each loop completed, we create a sequence from it. And then I'll say what needs to happen after what. Well, first of all, we need to Wait, my cat is screaming. So first of all, what we need to do is actually to move the boxes or scale the boxes according to the smooth array values that we get. And that's very straightforward. We just connect then 0, the first trigger from the sequence, to our for each loop input here, right? And what is going to be moving the boxes? Well, that's going to be the smoothed array, right? So the values will be read from the smoothed array as it's calculating how much it should scale, not move, sorry, scale the boxes. So from here, I just fish out a variable called smoothed array, get smoothed array, and we transform the boxes. As I said before, the accumulation of the values will just keep increasing more and more. So suddenly we'll have more values than we have boxes, and it's going to be weird. And they will just lock up because they will always just read the first 3 elements in the list. So what we want to do is, once this is done, once the boxes are transformed, then we will clear the array, right? I need to remember, yeah, we will just simply, for then 1, we will clear array, not set, there we go, utilities array clear. Which array should be cleared? Well, you guessed it, the smoothed array. Get smoothed array again, clear, and now it's reset to 0. All right, we're done, I promise, we're done. So, compile, save, check for errors. So, what happens? At every frame of the, not frame, but like tick of the game, these 4 magnitudes are created from these 4 bands, right? Then each of these magnitudes is split apart into separate segments and are smoothed out. Smoothing happens by accumulating over time a number of magnitudes, which is 5, I believe, 5 magnitudes for each band, adding them up and dividing them by the amount of how many magnitudes were saved, right? So average, it's literally, you add up the numbers, you divide them by the number of the numbers, and you get the average. So we average them out, right? In doing so, once the beat kind of increases, then it's going to be a slower increase rather than a jittery mess. It's much more averaged out. Once we have the values of these bands smoothed, we add them to an empty array. At the start, it's empty. First, second, third, fourth, right? We just populate the array with 4 elements. Then this loop, at that point, this loop ends, right? And this one triggers, completed triggers. It goes through here, and this sequence starts playing. First thing that plays is this line right here. It goes through every single box that we have here, 4 of them, and it chooses, first box gets the first item from the smoothed list, second box gets the second item, third box gets the third item, blah, 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 right? And it scales them according to it. That's all it does. Once that is done, this triggers, then 1, and then the smoothed array gets, zeroed out. So everything is cleared from it. And then the cycle continues. Another tick triggers, the new magnitudes are recorded, and blah, 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 right? And this gets updated, the smooth values get updated, and the boxes kind of move a little bit more. Let's see it in action. Play. M. Pick a song. Finger. Nope. Good. There we go. Much, much cleaner. And the cool part is that if I go into my functions, move out stream of numbers, and here instead of 5 I use 15, so we average out 15 time intervals rather than 5, and I choose the same song, this is going to move much smoother, right? So you can control the jitteriness of it. F1, by the way, for frame view, wireframe view. All right, this was I promise this was the most boring portion of the whole tutorial or course. The next ones will be more interesting. Whew. All right, next up, let's make a ball dance. That sounds weird, but I'm keeping it. First step is to get some materials in here. And the way you do materials in Unreal Engine, if you don't know, is you use a Megascans library. Typically, if you need some custom materials, then you just download them, purchase them and download them from the internet and use a slightly different pipeline or workflow pipeline. But in terms of Megascans, very easy. It's almost a built-in library. It's kind of a built-in library. You go to Window. Nope, you don't. You go to... Do you go to Window? Sorry, you go to create, quickly add to the viewport, to the project, sorry, Quixel Bridge, right here. Click on that. It will open up a new tab for you, which will say Bridge, and it might ask you to sign in, right? And you sign in, and then you can download, a bunch of assets and so on for free. For your project, which is very high quality, very great stuff. I'm really happy with what they have here. More importantly, the materials, right? So I have already downloaded this rock cliff material from Megascans, and I will just click on this. It's medium quality, doesn't matter. I'll export it as medium quality, and you can see that it immediately creates a new folder for me called Megascans, Surfaces, Rock Cliff, and here I have my material instance. Not just that though, if I double click on this particular material instance, I can also see that there's the parent material, which basically, oh, you can't see it, pop. There's a parent material, which basically means that there's a whole new world right behind what Megascans kind of presents to you. And since this is much more of a beginner kind of let's get used to audio visualization type of a course, we will not be diving into that. What we will be doing though, let's go back in here. What we will be doing though is creating our own material that can make a sphere that basically pulsates according to the music, according to the beat, and that's going to be awesome. Before we do that though, I want to create a sphere in, where are we? Viewport, there we go. Viewport tab right here. I want to create a sphere in my listen blueprint instead of these boxes, so that, the material kind of looks cool on it. On a box, the seams will not be as nice. You kind of want soft objects for this kind of a amorphous displacement. So to create a sphere, we go, instead of selection mode, we go to modeling mode right here. We go for model. No, we go for create. I'm being stupid. And we choose sphere, right? I can place the sphere anywhere, doesn't really matter where we place it. We have ourselves a sphere. A few things to change about the sphere. First of all, the radius. I kind of want it like a meter in radius, like a big boy, a big sphere. If we need to, we will scale it up even further. Then subdivision type box, that's great. Subdivisions 16. The problem is that if I change like 16 or 8 or 4 or 2. Well, you can really see 2, but you can't really see beyond 16 how many polygons there are, and we will need a lot of polygons. So instead, I will tick mark here, show wireframe, to see the polygons, and then here I increase to 32, nope, 64, nope, 128, nope, 256. Sure. I would like to go 512, but 256 seems to be okay. Then instead of for the positioning, I will say target surface, whatever, pivot location should be centered. Just like that. And then the movement should be like 0, 0, 0, 0 out. Just like that. Perfect. And I think we're good to go. Material, we don't care about the material. UV scale, we don't care about that. World space UV scale, I don't care about that. Okay. Yep, that's good. We hit accept. We hit accept. We wait. It's making it. It's making it. Making a ball for us. There we go. There's our sphere. The problem is, how the hell do you get this sphere into this actor, right? Well, you don't. You kind of need to find its parent. And also let's get out of the modeling mode into the selection mode here. So to get the parent of a sphere that we have just created, you can see here in the outliner, you select it, and here you see the static mesh, which has a funky name, and no, you don't. Here on the right hand side, bottom right hand side, you see a mesh, static mesh with a funky name. You click on this little icon here that says browse to, and once you click on it, it just goes third person maps generated Gediminas, that's me, and the sphere right here. So that's the static mesh that is represented here. If I delete the sphere in here, the static mesh still stays, right? Let me rephrase it for cool, or not cool, but really heavy sphere. There we go. That's a better name, right? So now we have this object right here. I just double clicked on it. We have this object right here that we can use anywhere in our blueprints. And the way you do that is if I go to my listen blueprint viewport, I open up my content drawer and I navigate to where it is. Was it third person maps generated Gediminas? There's the sphere. I just drag and drop it in. Easy as that. And now I have a sphere here, right? If I move it up, let me move it up, and actually let's move the boxes away a bit. Like that. Something like that. Compile. Look at it. Perfect. Now it's part of my thing, my blueprint, right? There's the sphere. This should go higher now, like that. Okay, so with this done, now we have a sphere in here. That's perfect. The sphere will need materials. So let's create a new in the content folder. Let's create a new folder called materials. Open up that one and create a new material in it. And that material is going to be called master, not master, but like a sphere displacement, sphere displacement, or something like that. We will be using it on this sphere. And I will immediately go to my listen blueprint, choose my really heavy sphere, and for it, for its material, instead of world grid material, I will expand this and choose something displacement, sphere displacement. There we go. That's it. Now they are connected. Now anything I change in this material will reflect on the sphere. I can show you. Open up that one. Interesting. We are, okay, this is a moment where we need to decide a few things. So there is this new experimental material pipeline workflow that will become the main pipeline in further versions of Unreal Engine, but it's still experimental currently. But I feel like for this tutorial to not become old, I need to use it. So we will be using it. If you're following along on Unreal Engine version 5.3, 0.2, 5.1, 5.4 even probably, you will need to enable the pipeline not automatically, but by yourselves. And the way you do it is if you go to settings, you go to project settings, and here you choose substrate materials experimental. You tick mark that. It gives you a warning. We don't listen to warnings. Substrate opaque material refraction. We don't care. Substrate advanced visualization shaders. We don't care. Well, let's choose the refraction. Why not? Right. And then it asks you to restart now. Right. So to restart for it to work. And I will hit restart. The moment I hit, save. When I hit restart, let's make this blinding. Once I hit restart, it's going to recompile every single shader that we have. This is going to take a little bit of time, like 10, 15 minutes, maybe 5. So I will continue the lecture once this is done. All right. So after we have restarted Unreal Engine, virtually nothing changed except that now all of the materials are written or calculated with the new pipeline, the substrate pipeline, which is going to eventually replace the current one, right? Let me position myself here. So if I now open up this material, right, you can see that the nodes are a little bit different. That's due to the new pipeline, and we have like additional buttons or levers to pull to make even nicer materials. With that being said, this can be replicated in the old workflow or old pipeline as well. So first step is to remember that rock material that I have, content drawer, where is it? Megascans, surfaces, rock. Come on, load. Okay, double click, load. Yeah, there we go. This rock material that we have, we will be kind of using it. Not really. We'll be using its texture. So let me close that and explain it in a better way. If I open up content drawer here where I have my sphere displacement material, I can select all 3 of these textures with the shift key and just drag them in right here. Texture samples, like that. And sampling textures is really simple, or not sampling, but attaching textures is very simple. And let me just do let's not do color yet. Actually, let's put the color texture somewhere here for now. And let's just work with these 2. So for instance, normals, right? RGB, right into normals. Wait for it. Bam. There's your normals, on the sphere, previewed. If I hit save, since this is our sphere displacement material, I go in here, looks great. I think this is a medium level material, so if I zoom in really close, yeah, you can see the pixels from really up close, but damn, who cares? It's going to be moving either way. There's going to be other problems at play. So that's just from normals, right? And then here, this texture sample is a unique one. If I select it, you can see that the name of the texture is blah, 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 doesn't matter. At the end, ORDP. ORDP means, first one, O, is ambient occlusion. Second one, R, is reflection. Or sorry, roughness. Second R is roughness, and then DP is displacement. This is a heavily condensed texture which uses RGB values, channels, to kind of compress 3 different textures into one file, right? So R, red channel, is the ambient occlusion, and it just straight up connects like that. Let me disconnect the normal vector for now, just so that you can see. And you won't be able to. Okay, doesn't matter. Trust me, bro. Trust me, bro. So that's your ambient occlusion. Maybe if I connect that to the base color, you can see it better. No, wait, it doesn't work in the base color. Anyway, trust me, bro. Then second one is the roughness, right? That's easy. We just connect that green channel to the roughness input, like that. Easy peasy. No additional kind of things to change. And the third one is the blue channel, which is the displacement. And the issue with the display, by the way, from the roughness, you can kind of see the difference in the roughness. I really hope that this is picking up. Yeah, you can see there the difference in the roughness. The displacement is actually, like, there's 2 ways of how you can displace stuff in Unreal Engine. And the one that we're going to be using is the actual moving of the vertices of the mesh. I guess it's more expensive than, I'm not sure which one is more expensive, but that's the one that we're going to be using either way. So, hey, that it is what it is. And it's called VPO, world position offset, right? And I could just yoink it in like that. It won't really work as well because it's too weak, but I could just take the blue channel, multiply by 100, and now connect that to world position offset, and it offsets. And it offsets weird, right? And the reason why it's offsetting weird into one direction is because this is just like strength that also has kind of a direction. It's weird. Basically what we want is we want to give it a direction for each point, for each vertex at which it should move, right? And we do that by using vertex normal VS, not sure what WS, world scale, vertex normal WS. What does VS mean? Who knows? It's a mystery. But basically this gives us the normals for every vertex. And if I just connect them as my base color, you can kind of see, you can kind of see them colored. 1 second. Right. So it converts the vector data into color data, right? So it gives us a vertex normals of each face. Very useful. We use those and we then can multiply. So first multiplication strengthens the effect of this. Second multiplication, multiply. Second multiplication, let's do it this way, gives that strength to the vector, to the direction, right? So now if I connect this to my world position offset, bam, spiky boy. Let's disconnect base color. Let's connect our normal map. Hey, starts looking a little bit like a rock, doesn't it? Hit save. Take a look at it in the viewport. See if there are any glaring issues. Ooh, maybe 100 is a little bit too much, isn't it? Okay, let's tone it down a little bit. So instead of 100, let's do 20. 5 times less. once we do 20 here, it's going to be much calmer here than it is here, but this is still pretty aggressive. But hey, that is starting to look pretty damn nice. Let's walk around it. Yeah, I love how it looks. Looks great. Okay, awesome. So we have ourselves a displaced sphere. And of course, the number, or rather the displacement, should be controlled through here. So the higher this number, the more that sphere is going to be displaced. Also, don't forget that we still have that color thing going on. We will be using it, but for now I just want to keep it as clean as possible, right? Because color kind of hides problems and issues. So we want this to be a variable. How do you make it a variable? Well, you hold number 1 on your keyboard and click, or you can just scalar parameter. You can do that as well, right? But the shortcut for me, at least, is holding 1, clicking, right click, and convert to parameter. And then name the parameter. We're basically creating a variable, right? And name the parameter loud. You know, how loud music is. And we connect that to our B input right here. And that is our loudness parameter. And by default, it is set to 0, and minimum and maximum slider values, we don't deal with those. We don't care. Okay. For now, we kind of put a pin in the material. We'll come back to it, but for now this is fine. And we have ourselves a little, you know, a little cute material here. Then, this is a master material. What we want is an instanced material. And what I mean by that is master materials, for instance, you can have a master material that has a variable set to its color, right? So you have a master material called plain color, and then you have derived materials from it, instance materials called red, blue, green, orange, whatever, right? And you change that variable to fit, you know, to become red, blue, green, orange, and so on. So that's the way it works. And this is our master material. If I right click on it, I can choose create material instance. And I can say sphere displacement instance, right? So now I have, you can see here, material instance. If I double click on it, completely different menu. But the interesting bit is that now I have this scalar value that I can change in real time. Let me show it to you. So first of all, I'll go to my listen blueprint. I'll go to viewport, select my really heavy sphere. And here for its material, I will change it from the regular one, from the master material. Let's go into our materials. I'll change it to material instance. Drag and drop in. Easier, faster. Compile, save. Virtually nothing changes, right? But now if I open up this sphere displacement instance, I tick mark this value, and now I change this value. You can see that I can displace this mesh in real time. Come on, that's pretty neat. That's pretty damn cool, isn't it? I mean, if I overdo it, then you know, it's a little bit stretchy. This is due to lack of polygons, right? We are displacing quite a few polygons, but we would need more for this to be even cleaner. But this seems to be quite nice already. Okay, let me close that. And now let's actually displace it according to the music. So I'll go back to my listen blueprint. I'll go to my event graph and I will say, all right, so for this sphere that we have here, actually we'll do one more trigger, because here we have play the music. We have here the tick. Actually, somewhere here I will create event begin play. When we start the game, really heavy sphere, I'll just drag it in like so, should have its create dynamic material instance. It should have its dynamic material instance created. So what we're going to do is basically we're fetching the material. We're fetching the we'll be fetching that variable, the loudness variable of the material. And from this sphere, we will get material. We just get the material, the current one that it has, and we just slap it on the source material, and we'll just connect it like so. So it's getting the current material and it's creating another instance of it where it will be changing its values, right? And then all we actually need to do, one second, thinking, we just need to set scalar parameter value. Parameter name should be the name that I chose here, loud. That's the parameter name. I think caps lock, like the uppercase, lowercase letters matter, so make sure that the value is correct, the name is correct. And the value itself, we we need to add up. Do we add up? One second, I'm thinking. Kinda, yeah. Yeah, we need to add up all of these smoothed array values into one value, one big value that is going to be overall loudness, right? So unfortunately, we'll need to do a few more shenanigans with this. Okay, let's drag this to the left side a bit. So the sequence, when do things happen? This will always be at the end, right? So let me just disconnect it and just drag it down to make sure that, I'll reconnect it later, but we clear the values after the tick is over. But when smoothed array changes the boxes, sure, that's the, I will select all of this and just C to comment, click the C button to comment. That's the boxes, right? Then I can take this smoothed array, get smoothed array. I can do for each loop, for each element of the array. So that's going to be the next thing that happens in the sequence. It's going to add to this kind of a overall loudness variable. So I'll create a new variable, call it loudness, and I'll just make a float out of it like that, and just drag it in get loudness. And basically, as we're going through this array, we just want to accumulate it, right? We want to add them all up into this number, so it's going to be easy. We take the number from the array, element number 1 or element number 0, and we add it to the loudness, and that's the new loudness value, right? So we just grab the loudness again, drag it in, set loudness, bam, and that's it's triggered by the loop body. So the way this works is 4 numbers, let's say 4 numbers come in. Yeah, it is going to be 4 numbers. 4 numbers come in. First number goes in here, gets added to the loudness list. So it gets added in. And the loudness is then set to that number. So let's say, okay, Where's my notepad? I'll explain it with a notepad. 4 numbers, 5, 4, 12, 1, right? So this loop is going to go 4 times. First time around, and currently loudness equals none, or not a number, right? Currently. So first loop, 5 comes in. 5 is picked because, you know, the loop starts, array is 1, it fetches the first element of the array, it fetches 5, right? And 5 is added to loudness, which is currently not even, you know, it's empty. It was empty. So 5 plus empty is 5, right? And then after this, the loudness is set to 5. So we set the loudness to 5 after adding it, right? Loop ends. Next loop begins. Currently, loudness is now 5, and then 4 comes in. 4 plus 5 is 9, right? So now loudness is set to 9. And so on, right? And it goes four times. So 5, 9, 21, 22. At the end of it, loudness is 22, and that is accumulated, you know, all of these magnitudes accumulated into one number. We have our loudness number. Once that is done, all we need to do is grab this. Okay, so C, calculate loudness, like that. Then this happens, and then actually set scalar parameter value does not happen once at the start, it happens all the time, right? On a tick. So after loudness is calculated, then we drag out here and we set scalar parameter value, and what that value needs to be, well, get loudness, bam, like that, just like that. We might need to adjust, of course, some values, but should be fine. Should be fine. Okay, with that done, it's going to be C. Send to material, right? This is useful. And then last one is, of course, after everything is done, the array, smooth array, that needs to be cleaned, but also now the loudness value needs to be cleaned, or else it's just going to keep adding in more and more, right? It's going to make it louder and louder. So we set loudness to 0. I just dragged it in and set to 0. Comment, reset everything. Okay, this should be good enough. Compile, save, play. Currently loudness is, or actually also let's do print string, and let's just print the loudness value on the screen. Play. Okay, it's 0, so there's no displacement. M, pick a song, good song, open. Hello? Okay, it's like 3, 4 in terms of value for the loudness. Once the beat drops, it's like 8. I wanted to transform more, right? I wanted to transform more, so we can either ramp it up, where is it? We can either ramp it up here, or we can ramp it up inside of the material itself. And I think I will do that inside of the, should I do that inside of the material? Yeah, let's do it inside of the material. So back in here where I have my displacement, I have my loudness multiplication. Wonder why it's so smooth. Oh, maybe it's smooth because I'm smoothing it like crazy. 1 second. 5 instead of 15 for smoothing iterations. Play, pick a song. I'll choose this now. Like 7s and 8s and 9s. Okay. Let's dial it in. So the first thing, 1 second, right here. All right, I think the only thing that we need to change is the exponent for the power. I think we're just cramming down, like pushing down the, we're softening the curve. Remember the curve, the mathematical curve? We're softening it too much. So I'll drop down the exponent to 0.5 rather than 0.3. And I think that's all we will need for this to kind of pick up instead of like 5-ish. Let's go. Instead of 5, for this to go higher up once the beat drops. Let's see. Okay. There we go. Okay, this is better. And any further adjustments can be done by just multiplying then, where is it? Multiplying this value before we feed it into the loudness, to the material parameter. Okay, we can move on. Okay, so that's the displacement. We have it here. Also, you can multiply it here if you want to. You know, whatever value you get, you multiply additionally by 2, and now it's going to be 2 times more aggressive if you want to. All right, now let's create a mask, which is going to be a little bit annoying to do, but I think we will manage. So I want parts of this to glow, and I want the mountains to stay normal, but I want the inside of the core to be like orange, hot core, emissive material. So what I'm going to do is I'll hold 3 on my keyboard and click. You can also type in constant 3 vector, same thing. I'll select it, click here to choose a color, and I'll give it like a very warm orange color, something like that. And I will not be plugging it into the emissive color just yet, or actually I can plug it into it so that you can see what's going on. Press save. Now audio visualization, you know, we have the sun, but I don't want it to be like that. I want the mountains to kind of form around it, and hide it, and only when the beat really drops it should start glowing. So first of all, the intensity of it should be controlled also by the loudness of the music. The louder the music, the more intense the glow is. So I'm going to multiply this value, emissive color, multiply connects now to the emissive color, and I'll multiply this value by, well, we need the loudness, right? So I'm just going to Control C, Control V, copy that loudness parameter onto here. And the problem is that if I just do this, it might end up being too bright and too jittery. Let's see, because you don't really have a lot of, yeah, this is at 0. Why is it so, oh my God, this is laggy. Is it because I'm recording? It's because I'm recording, isn't it? Yeah, okay, so it is working, but I don't have control over it, and I don't like that. So I'm gonna escape out of here. Also, access none trying to read private configuration. Oh, remove from parent broke. That's weird. Anyway, we ignore. We ignore. If it's a problem, then we will fix it. If it's a one-time thing, then we ignore. Right, so this, having more control over this, I will use remap value range, and I will choose a bunch of inputs and targets, right? So basically I'll say, what's the smallest loudness? What's the highest loudness that it should register? And then everything, and how it should kind of squeeze that number range, right? It's like remap numbers in Grasshopper. With like every programming language has certain ways of how to remap numbers. Anyway, so our input low is going to be 0. So I'm just creating a scalar parameter. Is it scalar? Constant. Sorry, it's just constant parameter, and I'm connecting it to input. If it's 0, then the output should be 0. But then if the loudness goes up to like 30, what should be the, how much should it output? I don't think it should output also like 30. It should output like 10, because 30 is insane. That's way too, whatchamacallit? Like that, it's way too intense. Right. So that's done. And now normal map goes like, go away, normal map. No one needs you. And now we need to select areas. Okay, this is going to be difficult. This is going to be the tricky bit. Because now for this emissive map, let me get it a little bit closer to the node. For this emissive map, we need to select areas that are not mountaintops. And to do so, we will need to use linear interpolation. All right. And our linear interpolation, sorry. Our linear interpolation will interpolate between the A input is going to be our emissive map, while the B input is going to just be nothing. So basically we're just cutting away everything that is going to be below the threshold. And for this we need a mask, so white or black mask of the mountaintops, of the displacement. Oh, this is getting yucky. Okay. But we can do that. Yeah, we can do that. Okay, let's really quickly disconnect the world position offset and disconnect the normal map. We'll connect those later. We just like look at the sphere, and I will connect the blue channel of my, basically my displacement map as my base color. So this is the displacement map on the sphere. Okay. Can we make it more contrasty? I think we can. So I can multiply this blue channel all the way to here. Multiply, and I'll connect it to base color to see, you know, how much brightness am I getting, and I'll multiply it by like 2. Does it make it brighter? I don't know. I will multiply it by 5. It definitely makes it brighter. Okay. So if it makes it brighter, that means that the tops, the hilltops, become brighter and brighter while the base stays dark, kinda. I want now to have a higher contrast. And I think there's like a cheap contrast thing. Contrast. Yes, cheap contrast. Perfect. Cheap contrast. I'll connect result to the base color. Okay, and now if I increase the contrast, also I need a scalar value. Constant value, sorry. Constant value. Right click, constant. Choose the first one. Connect that to the contrast. It's set to 0, but if I set it to like 10, hell yeah. Okay. Oh, it's just there though. So 5 is a little bit too much. What if we do 2 for the brightness? Okay, 2 is like a lot of areas. I don't like that seam one bit. That seam is annoying. I hate that seam. That seam is bad. Yucky, 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 yucky. Ew, ew, ew. Anyway. So how would this work? Oh yeah, this is the map, right? So I can connect the contrast. White areas would then glow. No, white areas will be cropped out and black areas, the A input, will glow. So if I do this, connect the contrast, no, not into B, god damn it. Connect the cheap contrast into alpha, like that, and connect alpha into my emissive color, instead of just, everything is connected to the emissive color. Bam. Then technically it should work. The problem is that right now it's set to 0, so that's kind of annoying. But if we just do this for just a second, there we go. Okay. So the valleys glow while the mountaintops don't. That's what I wanted to see. Now we can connect it back. And 5 is almost nothing glows, while 2 is a lot of things glow. That's good. That means we just need to make another version of this. So this is used for pulsating the light, and this is going to be used, Ctrl-C, Ctrl-V, is going to be used instead of a constant value to change how much of the valley is flooded with the emissive color. So we're changing the mask in real time as well. So if input high is set to 30, actually this is going to be a little bit more complicated one. Input low is 0, input high is 30. In target low is going to be, what was the number where it was almost no black spots? I think it was like 5. And this is going to be 2. Yeah, 5. You can see clearly here. And this is going to be 2 for target high. And now we are kind of good to go. Cheap contrast disconnects from the base color. Okay, let me double check. Comment, control the mask, comment, come on, comment, control the light intensity. Okay, oh yeah, that, comment, control the displacement. Okay, save. Without normal maps, so this is gonna look real ugly, but let's check. Let's try this out. Okay, just a sphere. Pick a song. Anywhere you go. Yeah. Oh, it's gonna explode, isn't it? Explode. Nice. There are issues. Well, you can see the seam, right? The seam is there because of the whatchamacallit, just the tiling, the UV seams, right? Which is sad, but it's part of life. Part of life. Spheres have to have seams. Let's make it a little bit nicer. So now, without having anything selected in the material, two-sided, I turn this on so that both sides are going to be visible. That's going to hide the seam a little bit better. Then the displacement was okay-ish. I think it was okay. Then the base color can actually now come in and connect. Because now we're not hiding anything. And the texture, the normal map also can come in. I'm just gonna have them like here. Yeah, that's good enough. Okay, save that. Let's play this again. I feel like this is going to hide it a little bit better. Okay, sphere looks great. Boom. Hit it. Nice. Nice, nice, nice. Okay. We have it going. Shall we make it more aggressive? I think we shall. So let's go into our listen blueprint or actually, wait, there was one band that didn't really, I think this one is pretty weak. Sorry, I have to test it again. Pick a song, anywhere you go. Which one is the low one? Okay, if I'm looking at the sphere from here, this is the first band and this is the last one. So 1000 is hitting pretty heavily, but the first one is not. And also, wait, when we play, which band does the beat rely on the most? Alrighty then, restart. Let's see how much we lost. I think I saved quite a bit. Oh, it's compiling shaders, 5000. Okay, we paused the video. Okay, we're back. I thankfully have saved quite recently, so nothing really disappeared. Save your files. That's important. Anyway, so I managed to figure out what was the culprit of this not being as aggressive as what I not hoped, but what I assumed it's going to be. And it was the bands that I was using, right? So we did like 50 to 100, 400 and 1000, right? But the problem is that the beat drops at much lower frequencies, you know, the boom, you know, that is a much lower frequency beat than the, you know, of the 2000 hertz and above. So now if tweeting, I guess it's called. So now if I play the same song at much lower frequencies, it's very loud for me. Let's wait. Now it's gonna, the beat is gonna drop much harder. See? That looks kind of cool, doesn't it? All right. So that works great. I think it's even a little bit too great. The multiplication here for the displacement, I'll have like influence of 1.5, save. And also for my listen blueprint, I will move the boxes even further out from the sphere. The sphere should move a little bit down, like that. And the boxes just kind of go even further out. And they can also be a little bit higher. All right, so that is done. Let's compile, save, see how this looks like. Doesn't look that bad. There's a shadow, there's a sphere. We're good to go. So does this end our chapter 2? This actually ends chapter 2. I thought we will never make it. Let's end it on a good note. This. A different kind of song. Right? Now, in chapter 3, we will move on to using Rhino, Grasshopper, importing models from Rhino into Unreal Engine and moving those models according to the song that plays, right? So again, we will use the same procedure. If you don't have Rhino, if you don't have Grasshopper, no worries, as long as you are able to download the files from Patreon, you can follow along just as easily. If you can't, then this is the end. This is where the course ends. But basically, there's not going to be additional information when it comes down to functionality. So for those of you who are here just for the Unreal Engine portion, hope you enjoyed the video. Leave a like, subscribe. And those of you who are nerdy for Rhino, I'll see you in chapter 3, I guess. Okay, chapter 3. Let's go. So you will need an element as well as a wall or surface on which that element is styled parametrically, and it kind of reacts to attractor points or whatever have you. I have here a little script, well, not a little, but like a Grasshopper script that I already did to test out, I need to make sure that this works before I show it to you, and it does seem to work. And let me just do one thing that I always forget, bifocals. It's just a plugin for Grasshopper that enables me to, show you the names of the nodes that I'm using. But basically the initial setup is very, very simple. You need to, first of all, go to units, type in units, and change your units to centimeters, because that is what Unreal Engine uses. And if you're importing stuff that's in millimeters or meters, the scale is will be out of whack. Second of all, create a box that is looking at negative x direction. And I know that it's weird that it's looking at negative x. Don't worry about it, just create a box like that. The measurements of my box here, this is going to be like a placeholder for the element, by the way, is around 110 centimeters, so 1.1 meter in its length, 3 feet, a little bit over 3 feet in the length, and then 20 centimeters in its height, and around 40 centimeters in its width, right? 40, 20, 110. And then for the arch here, it's made out of the edge, F10. It's made out of 4 control point NURBS curve that is just extruded. And I believe the distance between the ends is 4,000 centimeters. 40 meters? Is it 40 meters? That sounds like it's a lot. Wait, thinking. 400 is 4 meters, 4,000 is 40 meters. Okay, so it's 4,000 centimeters, and the height of it is going to be around, yeah, it's 5 meters. 5 meters high. Okay, now this surface, and it can be whatever surface you want to be. It does not need to necessarily be this shape, right? We reference into our Grasshopper file as a brep. Oops, wrong button. Now I need to get used to this. Set one brep. There we go. And we will divide up this surface into a grid of points, right? So I will say divide surface, divide surface, like that. I will use reparameterize on the S input of my surface, like so. Reparameterize, so that the UVs that come out will be locked to be between 0 and 1 in the range, rather than telling me the coordinates in centimeters. I don't need that. Then in terms of divisions, I'll just yoink the values from what 12 by 115. 12 for the U value, 115. You just double click and type 115 for the V value. By the way, I do assume that you have at least intermediate level knowledge of Grasshopper. Well, no, at least beginner level knowledge of Grasshopper to follow along. If you don't, there's plenty of... I'm going to be making a Grasshopper for beginners course. Wait for that. Anyway, we have ourselves a grid, and for that grid to work, I basically want to eliminate all of the points here and all of the points here, because if we start placing these elements on the end points here, that's going to be a little bit annoying, a little bit, you know, bad JoJo. So we want to end at this row. To do so, it's pretty simple. You just remove or cull index. Cull index for the points. God damn it, for the points. And your index needs to be //0 to create a panel with 0 in it. Hit enter to get another line, -1. So you remove the first item in the list as well as the -1, which is the last item in the list. If I connect it now, it's going to freak out and tell me that text to integer failed because it has multiple lines. And here you can just fix it by right-clicking on the panel and choosing multi-line data, unticking that, and now it's fine. Now it treats every line as a separate entity. Okay, with that done, how did I do this? Yeah, okay. So with that done, now I will take this brep again, and I will populate it. Populate geometry. I will populate it with random points. 10 random points, //10. Or you can just type in panel and then write 10 here. Don't hit enter, click somewhere outside, connect that, that works as well. //10 is just faster. Seed doesn't matter. So 10 points populated on this surface. And then I will, do I interpolate them? Yeah, I will interpolate a curve through them. This is going to be very random, very weird, you know, like that. With the curve interpolated, I will project the curve project the curve onto a brep. I'll project this curve onto a brep, the brep being my initial form. I'm in the way, am I not? Like that. brep being my initial surface, and the curve that I just generated being projected on the brep. But the distance, or sorry, the direction, the direction should be in the in the y-axis, right? So I'll just change this to, to Y. Bam. And now I get that squiggle thing projected onto the surface. And it's just a fast way of how to do a quick squiggly line, right, on the surface. Easy as that. With that line done, now I will measure the distance between each of these points. What's the closest distance from each of these points to the line? And we can just use pull point command on this. Pull point, those are the points that we will be pulling, and that is the curve. The thing is that now if I connect, you know, all of these points, they are in one graph, in one data tree, right? So meaning that they're in separate data branches, and as they're being pulled on the curve, I don't think that they are getting duplicated unless there's multiple curves. No, there's two, but they're not getting duplicated. It's just that we don't need a data tree system here. This can be just a cloud of points for all we care. So I will right click on the P input and choose flatten to get rid of the data tree information. So now the distances that come out will be in centimeters, right? And I can kind of show, no, doesn't matter, will be in centimeters. Right, and I kind of want to convert them to a range between 0 and 1 because it's much easier to deal with, you know, a proportion rather than distances or centimeters or whatever. So I will remap numbers like that. The source domain is going to be, well, range, wait, not range, bounds, you know, getting the minimum distances and maximum distance, that's the source domain, and they get squished to be in the domain between 0 and 1. That's all we need, and then we get our answers, right? So now if I multiply this by any number, it's just going to be cleaner, I guess, right? It's going to be easier for me to convert this to degrees, for instance, right? Speaking of which, now I should, 1 second, thinking, still thinking. UVs, no, we use the points, I think. Did we use the points? No, we do use UVs. Okay, I'm sorry. Just like I'm being such a stupid baka. Since we use the points here without them being culled, you know, this does not do anything. So instead of using just divide surface points, I will be using the culled points like that. And actually, just like I'm culling the points, I will be Control C, Control V. I will be culling the UVs as well, the coordinates of those points, right? And with those UVs, I will be evaluating evaluating the surface. This brep, right, gets evaluated at those particular UVs. The reason why I'm doing this is because then I get the frames here, and those are basically planes. If I zoom in, zoom, hello, planes? Wait, are they very small? 10 centimeters. Let's do 100 centimeter planes. That's weird. It should show. 1 second. Thinking. Still thinking. Untrimmed. UV. Oh, that's reparameterized, and this is not reparameterized. So we need to reparameterize this one as well. Yeah, so you right click on the S input and choose reparameterize, and now we're good. And 1 meter is too big for the plane, so I'll make them smaller. Like 20 centimeters, something like that. Perfect. So here we have our planes, great. And then with the planes, which are the frames, I just need to rotate them according to how close they are to the curves, right? We're doing an attractor point type of a script, right? So I'm going to use rotate 3D, and I think the planes should be flattened. Yeah, they should flatten that output. So I'll use rotate 3D. The planes will be what is being rotated. The angle, I right click on the A input, it's going to be degrees, change to degrees. The center is going to be the center of the plane, so they're going to rotate around their own center point. And the angle, well, that comes from remap numbers. And you can see here that I already did the graph mapper and another remap numbers here. And I think that's what we're gonna, yeah, let's not jazz things up. We will do the same thing. Graph mapper. This just remaps any, you connect that remap numbers to the graph mapper, right click, where is it, graph types, Bezier, and you can remap so that, you know, if you had 0.3 before, now it becomes 0.1, or 0.25 before, it becomes 0.1. If you had 0.5 before, it becomes 0.45, right? So you can adjust how fast values increase and decrease. So we do this kind of a sinusy thing. Well, I did an opposite of that. Doesn't matter. We'll adjust accordingly. So that's done. And then from these values, now we remap numbers again. But this time our target domain is going to be // and we write down the minimum degree and the maximum degree. I need to check. 30 to 130. Okay, / 30 to 130. So now I can explain this. We measure the distance between all of our grid points that we have here to the closest curve that we just, this squiggle. So the closest point from each of these planes gets measured, the distance gets measured, and we get it here. Then the distances get squished to fit in between 0 and 1. The proportion stays, it's just, you know, we divide them up so that the whole range is squished between 0 and 1. Then we apply this kind of curve to it so that it takes a while for the number to increase and it takes a while for the number to decrease, right? And then at the end of it, we convert it, or we expand it into a range of what kind of degrees we expect to have, which is 30 by 130. And those are now our degrees that we will use on these planes, right? So we rotate them. The question is, okay, what's the angle around? What are we rotating them? That's going to be the y-axis, the green vector of each plane, right? Green is y-axis. So we can just deconstruct plane like that, grab its y-axis and connect that to the axis input here. So now all of the planes are rotated. And I actually at this point can show you what's going on. I'm just, by the way, hiding all of the preview of everything except the final out, like this output here. I can do a quick SDL, line SDL, so start, direction, and then length is going to be like, let's do a meter long lines. And you can see that, yucky. Well, it's not going to be like that because this is looking in the opposite direction, but still, they rotate according to how close they are to the curve, you know, these lines. And I can change that by changing the graph mapper. It's very hard to see with line segments, right? Okay, let's move on. Let's actually position our element onto this plane, right? So to do that, we will use orient, just a regular orient. It's going to ask us for, okay, what's the geometry that you want to orient? That's going to be our brep right here, our box. So I reference it in as a brep, connect. The original plane from which is going to be oriented is world XY, and this is the default world XY, which is great, and is going to be oriented to all of these planes that we have here. Bam. Ta-da! We have ourselves a parametric wall that does things, right? And by default, it's set to 30, but when it is, wait, is it upside down? It feels like it's upside down. Wait, how does it look like if it's 30 to 30? Yeah, so 30 is like that, and 130 or whatever it was, it raises it, right? And we can control by how much. Basically, you can control the wave. Oh, this looks nice. This looks lovely. Okay, we keep it. So we get ourselves a parametric wall that is somewhat random because of this, but other than that, you have quite a bit of control. With that being said, I have modeled out. Select it. Boop. I have modeled out this sub-D shape instead. If you want the sub-D shape and you can't be bothered to model it, or any shape you want, if you can't be bothered to model it, Patreon, support the channel, link in the video description, you get all the files. I'm just gonna keep repeating that. Anyway, so this sub-D shape, I want to use that instead of the box, right? So I just reference in sub-D, set one sub-D, and just connect that to my orient. Like that. Oh, it's gonna be crashy, isn't it? Oh no. Oh no. Oh, can I escape? Oh no. Okay, don't do that. No, don't just connect sub-D. Convert it into a mesh first. Okay, thank God that works. I disconnect this immediately, and mesh from sub-D. Really? Oh, there it is. Mesh from sub-D, like that. And the density should be, for testing, just 0. And just connect that as our geometry. There we go. Okay, we have ourselves the, you know, a little bit more elegant element here, a little bit nicer. If I do custom preview, then you can see the cat. Come on, no, not now. Daddy's working. So if I do custom preview, then you can see, you know, that element in action, which looks pretty nice. Anyway, now we need this logic, this orientation logic, to be transferred from Grasshopper into Unreal Engine. And I already have in this YouTube channel, I have shown ways of how to do that, but we're going to be somewhat repeating it just for the sake of clarity and that everyone's on the same page. What we will be doing is we will be creating, I can show you, we'll be creating this kind of a list of things. Index, X location, Y location, Z location, X rotation, Y rotation, Z rotation, right? We'll be creating this kind of a panel, and we will be streaming it or saving it as an Excel spreadsheet. And then we will be using that in Unreal Engine, reading that and placing the element according to the data from the Excel spreadsheet. That's how we make it kind of talk. Should work, hopefully, we'll see. Right. So now after orienting, I can just do, first of all, indexing. Index is easy. I will just create a panel, / index, write index, enter. That's the name of the row or column of the column. That's the name of the column. Then I will just count, I'll use series. I'll just count how many elements are there, right? So list length list length, connects to count, series, it just counts, 1481, but we start counting from 0, so 1482 elements. And I'll just merge them. Merge that and that. And that's it. That's our setup, right? So I right-click, flatten, right-click, flatten to make sure that everything's in one list. We're happy, we can go. Right, so that's the index. Now for the location. Location is very easy to break apart. That is literally just the plane origin XYZ coordinates, right? So I can just deconstruct plane like that. I get the origin. I can deconstruct point, and I get the XYZ coordinates. And then all I need to do is just copy this bad boy right here. Well, I don't need the series, only this. X connects to this. I'll just copy it 2 times like that, like that. Y connects to this, Z connects to this. And I can just eliminate the D3 inputs. We don't need them. And this is going to be X underscore lock LOC, Y underscore LOC, and Z underscore LOC. Oops, okay. So that's done. Now we will be able to just place the elements, but now we need the rotation values, right? Which is difficult, really difficult. The way we're going to do it, okay, and the reason why it's difficult is because we need the yaw, pitch, roll rotation, Euler rotations, rather than the regular rotations that are used here in the Grasshopper. And to do that, we need a script. We need to actually write code, which is very, very annoying, but we can do that. Or rather, we don't need to do that. I will paste the code into somewhere. There is going to be in the video description, maybe a notepad file or something like that, that you can just copy paste right into your files. That's going to be accessible to everyone. Right, but this is the C# script that we need to write, right? And it basically takes the transformation information of this orient and converts it to Euler rotations. I can show you. And yeah, let's do it slowly. Copy paste, like that. And then it gives us degrees in, oh, there's no type hint, okay. It gives us degrees for roll, pitch, and yaw. And Unreal Engine X, Y, and Z. Right, if I double click on the C# script and wait, there we go, it loads in, and you don't care about anything here, but what you care about is this area right here, which basically it fetches the get yaw, pitch, roll from the rotation values that it gets from the translation values. Wait. Translation, transform from the transform value. Sorry. Anyway, I'll copy and paste this. I'll just make sure that when you create your own C# script that it works. So let me do it real quickly. Double click C#, C# script. There we go. Zoom in. Get rid of out. A needs more friends. ABC. Get rid of Y. Just leave the X in here, right click on the X, write transform without any capital letters, name it transform. A needs to be GH, capital letters, roll, small letters, Unreal Engine, UE, capital letters, X. Basically, the logic for this is the output is Grasshopper role, but in Unreal Engine, it should be the output is Grasshopper role, but in Unreal Engine, it should connect to Unreal Engine's X rotator input, right? Again, GH pitch, Unreal Engine Y, GH yaw, Unreal Engine Z. Okay. Now we're kind of cooking. I'll right click on the transform here and I'll choose set data item. Type hints. I'll choose type hints and I will find transform hint like that. The name A does not exist in the current context. There's no A. What do you mean? Oh yeah, that's if I double click on this, it's probably going to have, yeah, A equals null. There's no A, so it's complaining. Right, so this is where we copy and paste the code at this point, right? So let me just get it, and you will have this in the video description. Like that, copy. And I just, instead of A equals null, Control V, this whole thing, right? Play. It's happy with us. I can connect the X to here. It works perfectly fine, right? So we use that. Okay. Now I will just borrow this X, Y, Z location. Control C, Control V. And this is going to be X rot, Y rot, Z rot. Okay. And then for the role, I can't just connect it like that because, okay. I'm trying to think of how I can explain this. So there is the left hand coordinate system and right hand coordinate system. Basically, the difference between them is, if I have right here, you can see here in the corner, Y, X, Z, or even better, I can show you here. Left hand coordinate system versus, there we go. Images, these coordinate systems. Notice that they are different. Guess what? Unreal Engine uses one while Rhino uses the other. Suddenly all of the rotations and all of the alignments really mess up, and it's very annoying to get them to work, but we will. But because of that, we will need to do a few things. And one of them we already skipped, and we will need to come back to it. So the first thing that we need to do, and I'll double check, yep, the Y direction, Y location is actually going to go in reverse, right? So Y location, we create a negative like that, and Y connects to negative, and then it connects to Y location like so. Then for, let me just disconnect that real quick. There we go. Then for rotations, I need to double check. Degrees, yeah, that's fine. Oh, this gives us radians. Oh yeah, this gives us radians. So we do degrees for all three of these. For all three outputs, degrees. And only the Z rotation will need to rotate in an opposite way, I think. The opposite as well as 180 degrees should be added. 180 degrees, I think, because, yeah, 180 degrees because the element is looking away from the positive x-axis, but yeah, easier to add here. So negative, and then plus / 180. Add that in. Okay. Minimize, minimize, minimize. All right, we're done. Well, kind of done. Now we just need to assemble everything into one data stream, and then we're Gucci. We're flying. right? So I will use merge to merge all of these, and I think grafting is, so the output of all of these needs to be grafted and simplified. That's a mistake on my end. I should have done this before, graft simplify, so that they all come in separate data streams, data branches, but at the same time, once we merge them all together, they will be merged in rows, which is very, very useful. And that's going to save us a lot of time with editing. Okay, and then I merge all of these, and I'll show you how they look like once we are done. Okay, we're done. Bam. Then // if I show you the panel, first row, second row, third row, and so on. The thing about CSV files, the Excel spreadsheet files, is that they need to be divided by the comma. So different columns for each row need to be divided by the comma. So what we'll do is we'll join text, that's the wrong one, text join, we'll join the text, and the joining character is going to be the comma, like that. And now the resulting panel is exactly what we had in here, right? Ta-da! Right, so now to save this, we right click, stream destination, and we just find, I already have one, GHCSV, but I'll make another one, GHCSV YouTube YT. And for the files, not all files, but am I blind? CSV, comma separated value files. There we go. Right? Hit save. We're Gucci. Now we just need to click on stream contents, and now every time you update anything in your Grasshopper file here, this is going to update and is going to override the existing CSV file. Right. Finally, we can go back to Unreal Engine. Here in the blueprints, I'm going to create a new blueprint class. I'm going too fast, am I not? In the blueprints, in the blueprint folder, right click on an empty space and choose blueprint class. Should be here. In the blueprint folder, right click on the empty space, create a blueprint class, choose actor, and write parametric wall, or something like that, you know, the name for the blueprint. Also, import, or we can't import it yet, we need to create a struct. We need to create a logic of how to read the CSV file that we just wrote in Grasshopper. So we right click, and I think it's under input. No, it's not, damn it. Blueprint, yeah, it's under blueprint. Structure, we create a structure for reading, and we will say Grasshopper read struct, GH read struct, doesn't matter, the name doesn't matter of this. Double click on that, and here basically what we need to do is describe every column that we will have. So we will have 6 columns in total. Index doesn't matter. Index, we ignore index. We'll have xlog, ylog, zlog, xrot, yrot, zrot. Right? So here, first one, rename x_lock float. Then we click on add variable. It's going to immediately be float again. Ylock. Actually, I'm just going to add. There we go. Zlock, sorry, zlock. Then xrot, yrot, zrot. There we go. Location, 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 rotation, 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 XYZ, XYZ. Yeah, everything's fine. Save that and close it, and you will never open it ever again. basically. Then to import the CSV file, you just click on import. You choose, well, you find where it is. There we go, GHCSV YouTube, hit open. And it's going to ask you, okay, this is a data table for sure, but it's going to ask you what's the struct that it should follow, what's the structure, and we will find GH read struct, the one that we have created. Select that, hit apply. And now if I double click on this data table, you can see all of the nice values that we have here. Awesome. Xlog, Ylog, Zlog, Xrot, Yrot, Zrot. We will now read those values in this parametric wall actor, right? So I just double click on that actor. Open full blueprint editor. There we go. And now let's get rid of everything in the event graph. We'll create new ones if we need to. Let's go to viewport and sorry, thinking real hard, real fast, thinking, still thinking. Actually, let's just add a cube, and we will be rotating cubes for now. And then later we'll replace the cubes with our actual panels. That's gonna be fine. Let's go to the construction script. So the construction script is what runs before you even begin playing, right? So you can define that, you know, a thing should copy itself like 20 times, and it's going to be shown being copied 20 times in the viewport, even without you running the game. Event graph events only happen during playtime, during runtime, right? So that's the main difference between the event graph and the construction script. So for this to work, first of all, we need to get data table. We're in construction script, by the way. Get data table row names. We need the rows. And our data table is the Grasshopper CSV YouTube data table, like that. We get the row names, and now we need to go through every single one of the rows one by one. So we will, for each loop, you know this by now, right? For each loop, and we will get the actual rows from the names, right? So from this array element, we will get data table row. So we're looping through the whole data table and we're getting the rows. Don't forget to here also select the same data table, or else it's going to freak out, right? Here and here, these two, data table, table, important. And here we have the row, and we will break the row into these outputs. We break it, and now we can use these outputs to add instance. Damn, yeah, we need to add. 1 second, I'm still thinking. Damn it. Let me see if this will work. No, this won't work. Okay. So let's go back in here. The cube is a static mesh, not an instant static mesh. So if you multiply the cube many times, it's going to not be happy. Unreal Engine is not going to be happy. Instead, what you want to have is instance static mesh. That's not a problem to do. All we need to do is just delete that cube and instead add instanced static mesh, and we'll just call it element, right? Right now it's empty because it does not have any form associated with it. But if you select it and here on the right hand side, you click on none, then you can choose whichever, you know, shape you want. And I want the cube. Cube, please. Just a regular cube, please. There it is. Just a cube, compile. And it's not going to display. I don't remember why. I'll need to remember why. Come on, remember why. We'll figure it out, I guess. Right? Anyway, for now it's not displaying, but I'll see. We go back to construction script, and now we can drag it in here, and we can add instance. Yeah, there we go. Add instance. So we're adding an instance. If row is found, the instance should be added, and it should read these values and create a transform, right? So what I'm going to do is make transform, and location, that's going to be make vector. And we basically just connect X location, Y location, Z location to the make vector. Then for rotation, it's going to be trickier. It's going to be make rotator, not make vector, but make rotator. X rotation, Y rotation, Z rotation. And for the scale, we don't care. It's just going to be 1, 1, 1. We don't mess with the scale, right? And technically, if I compile and save this, yeah, there we go. There it is. Now the boxes are indeed there. Happy. Okay, now if I just go to my map, I can just drag this in and I can see, well, it's very hard to see, but I can kind of see the boxes here doing their thing. Maybe at this point we should make this a little bit bigger. So I'm going to increase the attenuation radius a bit to like 2000, and that should make it nicer, right? So this is how you can have like 2000 cat. Come on, no. This is how you can have like 2000 boxes. Well, in this case boxes, and not sacrifice any performance whatsoever. And it looks kind of nice as well, even with the boxes. Okay, now let's go to the event graph and make them spin, right? That's what we want to do. So in the event graph, what we're going to do is we're going to say on every tick, so event tick, get this element and get, so I just drag and drop it in, get this element and get instance count. So basically count how many boxes, in this case, how many elements do we have. And then we will, for loop, we will create a loop. Sorry, it's not going to be the first index, it's going to be the last index, like that. And we're just going to go through every single box and we're going to update its orientation, right? Its transformation. So we're looping through the boxes, and what we're going to be doing is, I don't know what's the best way. So we're going, let's say we're looping, and we're at box number 585. So this index will be used to get item from these boxes, right? What are we looping through though? 1 second. No, that's going to be fine. So we will use a command called update instance transform, and it's going to be for the element, right? And here it asks us actually for what's the index, what's the instance index? Easy. That's the current index at, of the loop in which we're at. Easy peasy. And loop body just connects to here, I think. Yeah. So this triggers every time. And now, okay, during this whole thing, as the transformations are updated, new instance transform should be made, right? So the new instance transform is, okay, make transform. That's easy. Nope, not relative. Make transform, a new one. Scale 111, that's fine, but the location, actually location doesn't matter, and rotation matters, right? So location we can just get. How do we get the location? Oh, I know a way. Compile. Go back to the construction script, and the value that we get for each, the transformation that we create for each of the boxes or elements, we can just save it into a variable, right? Into a list, into an array. So here under variables, I'm just going to create, click on the plus sign for the variable, and I'll say saved transforms. Saved transforms, and the flavor of it is transform, and it's going to be an array. So top right corner, you change it to an array here, because we're going to be we'll keep adding to the array, right? Maybe not saved transforms. I will rename this to initial transform. So this is where it starts from, right? Initial transforms. Bam. Get initial transforms, and then add to this array, and we're going to be adding this make transform, the transform that we just made. We're going to be adding it to the initial transform array, like that. And now of course the wires need to go through this add, just like so. So as we're looping through the whole list, right, and creating those boxes, we're saving their transformations, so that in the event graph, once we're in the event graph, we can take the initial transforms, get initial transforms, and we can get a copy from them. So we can extract a particular index from the list of transforms of that particular element that we're about to update, and we can break the transform to get the location. Also, you can get the scale if you want to. And the rotation is going to be the only thing that's going to be updated, and actually not even the whole rotation, but only the Y rotation. The Z and the X will not be, we just transform it like that, right? So we can break rotator, not into axis, just break rotator. And here we can make rotator, and X as well as Z will be, will not change. Y will change. Okay, almost there. So now, we need to get the loudness. Remember, let me compile this real quick. Listen blueprint, event graph, here. There we go. From smooth array, we just record the loudness, and then we parse that loudness into our material. We'll do the same thing with the Grasshopper. So at this stage where we send it to material, we will also send it to our wall, right? So after print string, we can say get all actors of class, and we will find parametric wall actor that we have created, get a copy, right, of the parametric wall actor. And now we need to write into a variable that we have in our parametric wall actor. And to do that, we need to create an actor here, or sorry, a variable here. So on variables, I click the plus sign. I say loudness. Make it into a float, and it's not an array, so I'll change its flavor to single. Drag and drop in get loudness, right? Compile. Then back in the listen blueprint, we will set loudness, because now this with these two nodes, we're in the parametric wall. We're getting into the parametric wall blueprint from our listen blueprint, right? And we're just going to set the loudness according to the loudness here. Actually, that variable is, I don't think it's pedagogical for me to use the same variable name. So here I'll change loudness to parametric loud. Parametric loud, like that. And here we will set, I need to compile. And here we will set parametric loud with the loudness variable that we have in our listen blueprint. Get loudness, bam, like that. Perfect. Okay, compile, save. Now I will, of course, save everything and connect the parametric loud to pitch to the new rotation, and we will just check if things move at all. Where's my wall? Oh, there it is. It's just very dark. M, pick a song. Music, pum, 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 pum. So it doesn't move. It doesn't move because of one thing, and that is where we have update instance transform in our parametric wall blueprint. Mark render state dirty. This needs to be tick marked so that we push the render of it even when it's, well, not necessarily not ready, but you can see that immediately it shows up. And if I pick a song, good, open. Okay, that works, but it works poorly, so let's make it work better, right? Because we have original values, right, of this pitch, these pitch values, and they are between 30 and 130, because I know, because that's what we wrote here, 30 to 130. The problem is that, what's the problem? The problem is that in Unreal Engine, everything is kind of rotated 90 degrees downwards. So 30 becomes minus 60. It is what it is. So just deal with it. So while in Grasshopper we define something as 30 to minus 30, in Unreal Engine that's going to be minus 60 up to 40, no, 70, up to 70, right? Minus 60 up to, no, up to 40, yeah, minus 60 up to 40. Okay, so what we need to do here in Unreal Engine is take this loudness value and we need to map range clamped, and we need to say that when it's not playing, when there's no loudness at all, it should be 0, but when it's playing, you know, what's the maximum? Around 25, according to what I saw with the numbers on the screen, you know, with the how big the numbers got. It was 25, 30-ish. And then for the output range, that's going to be minus 60 at minimum, and at maximum, when it's loud, it should lock into the existing pitch that we have exported this with. So this is always going to be the maximum of how much the whole wall transforms itself, right? And locks itself down. And then I connect that to the pitch, like that. Compile, save, play. Hope that it doesn't crash. Pick a song, anywhere you go. I'm waiting for the louder music. Oh yeah. Hell yeah. All right, so that's working. Save. Now all we need to do is replace the element, the cube, with, not a cube. So I'm going to go to content, right click, new folder, shapes or geometry, double click. And here in Rhino, I will just, for my sub-D, I will make another mesh from sub-D. But this one will have density of 1. It could have a density of 2 if you want to. And I'll just bake it, right? So here we have a mesh version of my sub-D. And then I just export it. You understand what's happening, right? I'm basically just exporting this. I can't export a sub-D into Unreal Engine. It's not going to understand what it is, but it does understand meshes. And I'll just weld the mesh as well, just so that it's clean and nice and dandy. And I'll just export it as a FBX file. Bam. I have it somewhere here. Element, there we go. And just hit save. My options for exporting are like these. Map Rhino Z to FBXY. That's tick marked, right? And just hit save, and then it's gonna export. Once you've done that, then you just hit import, you navigate to your file, open, failed to create asset. Content detect import type, no meshes found in animation. What? Okay, we try again. 35 kilobytes. This is fine. It's fine. Open. Okay, fine. I override this then. I don't know why. It's not being good to me right now. So motion builder, element YouTube FBX, save. That is saved. Okay. Close that. Import. YouTube. Open. Oh. Failed to create asset geometry. Please help. Okay. Okay, I restarted Unreal Engine and it seems like it just works now. Okay. So if you have this problem, just restart Unreal Engine and then you're good to go. Anyway, we have ourselves the element. I just selected it. I will build nanite for it. Or actually, yeah, I will build nanite for it. Everything else is fine. We don't need to change anything else. Import. Smoothing, groom, yeah, whatever. And here we get ourselves the static mesh element that we're after, and it's its material is set to to black, but if you open it up and recompile it, it's going to be turning white. I will just make it a little bit less white, like that. Save. Overly bright materials are a little bit annoying. Right, so with that done, Now this is our element, and now we can, yes please. Now we can open up our parametric wall blueprint, go to the viewport, select the element, and switch the cube for our element, like that. Material automatically updates, compile, save. Oh, they're inverted for some freaking reason. Interesting. Why? So 180 was not necessary, I guess, I assume. That's fine. I'll show you how to fix it. For now, I just need to make sure that it works. So let's find music. Dip, 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 boop. Yeah, they're kind of moving. Okay, and they're going downwards, which is weird because they should be going other way around. So I think I messed up with this. But at the same time, this seems to be okay. So my guess is 180 is not necessary here. The cool part is that now I can just disconnect 180 from here, like that. Like troubleshooting this kind of system is very easy. I just disconnect. I don't even need to do anything here. I just go back to my blueprints, right click on my data table, re-import, go to my parametric wall, compile, bam, automatically recompiles. This looks correct, right? Unless they will start moving upwards, then that's gonna be bad. Yeah, they are all looking upwards, so that ain't good, but that's fine. We will make this work. I wonder why did the last ones. All right, okay, so it's almost working. It's almost working. So what we need, this is looking upwards. So that's minus 60, right? 1 second, minus 60 is upwards. And then it goes downwards. So we don't need it minus 60 anymore. It's weird. Like the conversion between the right hand side coordinate system to left hand side coordinate system is always funky. So this indeed does need to be 30, not 60 anymore, or even more. Wait, play, look at it. Is it looking downwards now? It indeed is. Pick a song. I'm gonna pick a simpler song like that. Yeah. It's a bad song to test this out on because the bass line is very constant, right? So there's no vibration from the beat. There's almost no beat. But that seems to be working quite well. One thing that I noticed is that it's very easy to reach the 25 overall loudness value. So I'm going to go for 30, you know, and just get that ceiling up a little bit. Let's do this again. Pick a song. Come on, and there we go. Okay, we are almost done. We are almost done. I'm happy. Are you happy? I'm happy. So we did this 90 90 90. We did this when you press play. Yeah, that's good. And then we will get another one. Oh, the boxes though, those can be on the opposite side, right? So I'm just going to go to listen blueprint viewport, get those boxes in here, F to them or focus on them, and just yoink. The character is spawned somewhere here, so I'm gonna place the boxes there. Yep, that sounds about right. This moves out a bit like that, and the wall, let's make 2 more lights. One here, E, like that, like that, W. Maybe sliding shadow like that. Let me just check. Nah, I actually kind of like this more. Just a little bit higher. There we go, something like that. And the brightness is okay. Attenuation could be slightly larger to 300. This should be cold, this should be white. I think we're done. Oh, I eliminate also the, where is it? Event graph, print string, no need to print anymore. The numbers. We're done. We're done. We're done. File, save, and just enjoy. Where is it? New editor window. Full screen it. There we go. Pick that song. Anywhere you go, you belong. Ooh. Right. I hope you enjoyed this one. If you did, leave a like, subscribe, tell me in the comments. It was a long one, I know. I tried to explain as much as possible. It is a little bit more difficult of a procedure than just to do visual stuff, that kind of reacts to another medium, but it is fun. And hopefully you will it will get your mind going and you'll figure out ways of how you can incorporate into your own creations, even if you're not into audio visualization, but perhaps, as an architect, there is also a way of how to use sound for you, right, in your designs. With that said, I'm going to go and sleep now. Thanks for watching. Bye.